All right, guys, morning again. So you know the program. So each question that we're doing today, I'm going to give you 10 minutes to do it. But that's what it's all about now. We have to practice. Come in here to watch. So sit and watch me solve question, not helping you. All right? So you all have to try the question first, do the questions first. I give you 10 minutes, and then I'll go through and explain. Remember, you are selecting the question. So start in the first 2 hours doing question fours on any past paper from January 2016 to January 2025. So you're going to be selecting the questions that we are doing. After question fours, we take a break for half an hour. They will do question threes. After question threes, we take a break. They will do question twos, take a break, the question ones. And then we're going to go back and do question sevens. I didn't do sevens yesterday, which is the pattern question. So we're leaving the pattern question for last. Now, if we can get through this session before 9 p.m. tonight, that will be good. I know some persons have exam tomorrow, you have school tomorrow. So I think we can maybe speed up. And some of the questions you might not need that amount of work on, like maybe question 2 and so on. Some questions you might not need that amount of work on. So remember, it's all up to you guys. All right, so this is the first one. Put up the clock. I'm here talking, I won't put up the clock yet. Hold on. I send this one to the group because the question kind of lengthy and it's not so clear on the screen. So you can check your phones and actually view it off your phone. All right, so let me start this first 10 minutes. Same thing for the persons online. 10 minutes to do the question. And you can also call in question that you want to do. People are online. Date is 10 minutes for this one. Put it right in the middle here all the way. 10 minutes. First 10 minutes.
Sir,
Yes,
is there a part B?
part B.
As in, I'm seeing A, C, and D, but I'm not seeing a B.
Good question. Yeah, part B is at the top there. Oh, yeah. All right, I'm going to. Yeah, part B is up here.
All right, thanks.
Are you ready? Remember, find the next question right away. That's the one. All right, guys. So this question is usually a nice question to do, especially when they give it a graph, as they did here. I've been doing that in recent times. Because what it means that much of the information you can actually read it or count it off the graph. For example, the gradient, you can count off the rise and count off the run between 2 points on the graph. You can also see the y-axis intercept on the graph. You can see the points of intersection and so on. So based on that, this work is normally easy. It's coordinate geometry, but here no, you're not working blind because the graph is there. And the calculation in the graph must sync, must be consistent with one another. So whatever you get by calculation, it must also match what is on the graph. All right, so they give us these two lines, right? In this question. Line M and line L. And you should know that line M right on side is a positive gradient because the sloping upwards from left to right. And line L has a negative gradient sloping down from left to right. All right? So the question is asking some simple things first. The x-intercept of line L, that's this point, is asking us for coordinates, plural. Coordinates mean you must give the x and the y value of that point on the x-axis. So that point clearly is 6, 0. So this point is 6, 0. This point right here, where L crosses the x-axis. Then they're asking for the point, the y-axis intercept of M. So M, this is asking us now for this point, the y-axis intercept. Again, we must give both. At that point, now the x value is 0 and the y value is -2. But then that point, simply 0, -2. Right, if you write 0, 6 for this, you're wrong. If you write -2, 0 for this, you're wrong. So even if you have the same two values, but they're in the wrong order, you are wrong. You have to always put the x value first in the bracket and the y value second in the bracket. All right, so that part was easy. Just to write down those coordinates. I'm going to leave the graph on the screen here and work on the right side. Let me bring this plot down the bottom of the way. All right, so part B said, the equation of line L is this. So they're helping us. They're telling us the equation of line L, right? That's this one. The equation of this line L. And the question says, we have to find the value of K, given that this point 9K is on the line L. So what it means is that if this point is on the line, it means that it satisfies the equation of the line. Then you can substitute those values into that equation and it will be true because the point is on the line. So what it means then, at this point, the x value is 9. So we can use this and plug it in for the x value. And the y value is K. We can use that and plug it in for the y value. Simple as that. And then solve for the K. The point is on the line. So the point satisfies the equation of the line. And that's what we're going to do. Let's substitute the values in there. So we're going to sub into the line and we're going to get the x here becomes 9. So we're taking the point, I was subbing into the equation of the line. The x here is at 9 plus 2 times the y is at K minus 6 equals 0. They're solving this for K. This is 9 minus 6 is 3. So it's 2K plus 3 equals 0. Transpose the 3 and then divide the 2. You get k equals minus 3 over 2. Something is wrong. Something is wrong. Because you get it. Yeah, it's right. It's minus 1 point. I'm just looking at the graph as I work. It's actually this point out here now. We're talking about, right here. See, at this point on the line L, that's the line L, right? This is where the x value is 9. And right here, you can see that the y value is negative 1.5. See here? This is negative 1. This point right here would be 9 minus 1.5. So you could actually have looked at the graph and get it. But the only reason I prefer to calculate it is because this is not a precise point that you want to trust in terms of where that point is. I prefer to calculate it. But you see, that's where the point is. 9 negative 1.5. That's the point the question is talking about. All right? That covers that part. The next part, you better go to that, by the way. But okay? The next part says we are to find the equation of line M in this form. And when you have the graph, you can get it. This is the gradient, and this is the C. So let's look at the graph for that information. Line M. This is line M. So I want the gradient, common M. All I need to do is count the rise and the run between two known points to get the gradient. Any 2 points on the line I can use. Any 2 random points that I know for sure. So I can maybe say, all right, let me use this point. Let me do it in red. I can count out the gradient. I don't have to calculate it. I can use this point to this point. This is the line segment here. What's the gradient in that line segment? Count the rise and count the run. You rise 2 units up here, and you run 1 unit there. So the rise is 2, and the run is 1. So the gradient is 2 over 1. Rise over run is 2 over 1. And then the C value is right here. This point is the C value, you know. This is the y-axis intercept. This is the C. So the C equals negative 2. And the gradient is 2 over 1. So the M is rise over run, which is 2 over 1, which is 2. And the C based on that is negative 2. And so the equation becomes y equals the M, as we said, is 2. It's 2x, and the plus C is negative 2, minus 2. That's the equation of that line M. But go to that, nice and easy. We'll come down to the next part here now. It says, show by calculation that line L and line M are perpendicular. You have to know that perpendicular lines have negative reciprocal gradient, but also that when you multiply the gradient, you get negative 1. That's a good way to show that they are perpendicular. By multiplying the gradient, and the result is negative 1. Get me? So we have the gradient of line M already, right? Which is this M right here. Let's put a common M on it. Let's put a subscript M on it. So we're talking about the gradient of line M. So the gradient of line M is 2. We need to work out the gradient of line L. You can get 2 ways. You can get it from the equation that they gave us up here, but that requires calculation. So instead of getting it from the equation, we can count it off on the graph again using any 2 points. This is line L. I want the gradient. So again, you choose 2 points and you try to see how do you go from the 2 points, rising and running, go from left to right. So I'm going to use this point, just any 2 points, and I'm just randomly choosing this point to this point right now. Going from left to right, what is the rise and the run? Just make it easy by going from left to right all the time, along the line. So to go to those, between those 2 points, I would have to rise this way. That's down. When the rise is down, that's negative. So my rise is negative 1 this time. Then I have to run 2 units here, so this way. So my run is 2. So this is the run, and this is the rise on line L. So I can write over here, the gradient of line L is rise over run again on that line. And on that line, the rise is -1/2. The run is 2. When I multiply the gradient now, the gradient of line M times the gradient of line L is equal to 2 times -1/2. 2 times -1/2, which is -1. Let's start this again, which is -1. And this means that they are perpendicular. By getting the gradient equal, the product of gradient equal -1, this is what means that they are perpendicular. Therefore, as I show by calculation, therefore, M is perpendicular, a symbol for perpendicular to L. By getting the product of the gradient equal -1, that is your calculation. But go to that. All right, then you come down here. It says line L and line M represent the graph of a pair of simultaneous equations. It says, using the graph, write down the solution for the pair of equations. Simultaneous equation. When you solve simultaneous equation, you are really finding the point of intersection of the two objects. The 2 lines, you're finding the point of intersection of the 2 lines. The line and a curve, solving simultaneously, you are finding the point of intersection of a line and a curve. So this information is referring to this point right here, where the line and the curve intersect. They pass through this point simultaneously, the 2 lines. So when you solve the 2 equations simultaneously, that point, coordinates of that point will be your answer. The question said, using the graph. Using the graph. So I would show that I use the graph. I'm marking this point and just write maybe something like solution. Right here, solution. I'm not gonna write too much. Solution. And down here now I write solution would be the point 2, 2. And that point is 2, 2. So the solution for the pair of simultaneous equation will be the point 2, 2. That point is clearly 2, 2. So just to show that I use the graph, that's why I'm doing this on the graph. When the question says use the graph, you tend to want to put something on the graph to let the examiner see how you use the graph. Don't just let it for them to pick. Put something, some line, some marking, whatever, so that they can reference your work to say, yes, this person did use the graph, for sure. But that is the answer, guys. Any question on that? But okay? All right, so which other number 4 y'all want to do? Let me bring it up on the screen. Which other number 4? Which year? Huh? 2022, June? June 2022. All right. You want June 2022. That's it. June 2022, number 4. You want the functions, you want all of it, or just the B part? All of it? All right, so part A is a functions, and part B is your point geometry. All right, so I'm giving you 5 minutes for the function. You don't need so much, I'm giving you 3 minutes for the functions part. See there? 3 minutes to that part, quickly. 3 minutes. I'm going to time in 3 minutes. I don't know. I want to time in 3 minutes on my phone. I'm not going to put up the clock yet. 3 minutes now, 9:41. Stopping at 9:44. We do this function part quick for me, quick. This functions part. Let me bring up the next one over here. I'll give you about 8 minutes to the next part. 2022 June. The next part. I finished that part first. Part A. I never do the next, I never do part B. I give you 8 minutes for part B. It's those things I wanted to do with those two functions. Give it 2 more minutes. Don't go down. No, that's the only part of it. There's nothing else. The first part here is just this. Finish already? Body done? All right. We'll just do it then now quickly, and then I'll give you 8 minutes of part B. Let's finish it too. So this one, you give us these two functions, f and g. First part one's g of a third. So we're going to put a third in the g function right there. So this simply becomes equal to 3 times a third minus 1. 3 times a third is 1. This is 1 minus 1, which then works out to be 0. And then here now, they want f to the minus 1 of negative 3. Now, this can be done 2 ways. You can find the f to the minus 1 of x first and then plug in the negative 3. But I like to just set it out and say, okay, put it equal some number. I'm going to say, all right, put this equal some number n. Some number it is equal to. When you find n, you have found the function. So I would say if f to the minus 1 of negative 3 equals n, then the negative 3 is equal to f of n. And then what is f of n? F of n now is when you plug the n into the f function. So it means that the negative 3 is equal to 5 times n plus 7. The negative 3 is therefore equal to 5 times n plus 7. You still have to transpose. We're going to get the value straight like this. You have to do the inverse function and then substitute. When you get the n, you're done. So we're trying to find n. Take this 7, bring it over here so first and subtract it. So we're going to get 5n equal negative 7 minus 3. That's negative 10. So we're going to get negative 10 equals 5n. You divide by the 5. Let's continue up here. Divide by this 5. You're going to get negative 10 over 5 equals the n. And so the n is equal to negative 2. That works out to negative 2. So the n is equal to negative 2, which means then that this is negative 2. So we can say, i.e., that is f to the minus 1 of negative 3 is negative 2. But good, whether you do it this way or another way, it don't matter. Answer is negative 2. But all right, good. So if you find the inverse function first and then plug in the negative 3 to get the negative 2, that's also fine. All right, ready now for this question now. See here now. So to give you this graph on the first page, all they're asking you to do is to write down the equation of line L. So give you the graph of line L. This is that line L. You can still look at it. This is that it pass through 1 right here. And then again, you can count out the gradient, choose 2 points and count out the gradient. You must always check the unit of measures. So for example, this distance is 1 unit horizontally. This distance is 1 unit vertically. So this first part wants to get the equation. Over here, we're going to bring up the second part. All right, the second part is all of this. It's a little bit small. So all they're asking you for on this part now is this. All right, I'm giving you 8 minutes to do this. You don't need more than 8 minutes. Let's put 8 minutes on the clock. There you go, 8 minutes. I'm putting it right here. There's no question in this region, so I'll put it up here. Out the way. 8 minutes to do that first. Go on. No, printing papers in the group. We can. And they're not going to come. So me, we're not going to come. Ten 22. Just down 4. You want too much stamina. So 5 minutes, 8 minutes too long, run. Give it too much time, but so you only 5 minutes, not the 8 minutes. That's an easy. But that's how you can't drive. It's only problem. It's a vehicle that's time, they don't say what. Everybody ready? All right, I'm gonna stop it now. So this question is just this line L, and it wants us to write down the equation of line L. So as usual, we need the gradient and the y-axis intercept. Graph is in front of us. We can get it from the graph. This is the y-axis intercept right here. Passes through 1, so we know that C is equal to 1. That's the first thing. Then we need a gradient M. To get the gradient M, it's the same thing. We need to count out the gradient. We can count it off. We don't have to calculate anything because we have the graph. Choose any 2 points that you know for sure on the graph. Like for example, here and here. When from left to right, you want to count the rise and the run between those 2 points. So this is 1 unit up. It's a positive 1 rise. And this is 3 units to the right. That's a run of 3 units, positive 3. And so the gradient M, rise over run, in those 2 points. That's an easy. Rise 1, sorry. Run 3. So the gradient is the third. So the equation becomes y equals mx, third x. I see some people forget to put on x sometimes. Third x, and the plus c is positive 1, plus 1. Easy like that. Over here now, tells us that there's another line. Y equals minus 2x plus 8. Looking at this line, automatically you know that the gradient is minus 2 and the y-axis intercept is 8. So you can do anything you want with this line, right? But let's follow the instruction. It says write down the coordinates of point Q, where it crosses the x-axis. Instead of saying x-axis, they could have said the line y equals 0. I've seen them do that in question before. We crosses the line y equals 0. Remember the x-axis is the line y equals 0. But that's what happens. On the x-axis, the y value is 0. So on the x-axis, the y is equal to 0. So to find the x value, you could plug the 0 inside here. And then you will get that 0 is equal to minus 2x plus 8 at that point. Bring over the 2x and make it positive 2x equals 8. Until the x is equal to 4 at that point. So that point Q is 4, 0 on the x-axis. That's the answer, 4, 0. Then now it says, write on the coordinates where Q crosses the y-axis. Instead of saying y-axis, they could have said the line x equals 0, but that's what happens on the y-axis. X value is equal to 0. And that's really the y-axis intercept, which is the 8. Right? Because if you take this 0 now, you plug it in there, this is going to become 0. So you're going to get y equals 8. So this don't need no calculation. The y value is 8 at that point. And the point to the y-axis intercept. But it's not point Q. The line is Q. Or the line is Q. I'm naming the point Q. The line is Q. So that point they're talking about is the point 0, 8, not Q. So those are 2 points on that line. And they ask us to find those 2 points.
So you can go for question A.
Huh?
You can go for question A.
Over part A?
Yeah.
Don't wait till I go on far in part B next time. Ask it same time as me done. So basically, you want to find where this point crosses the x-axis. You have to know that on the x-axis, the y value is 0. And all you have to do is substitute the 0 for the y in the equation. Let me do it over again. That's where you start. You have to know that on the x-axis, the y value is 0. And that is why the equation of the x-axis is actually y equals 0. So if you want to find the x value at that point, because the question asks for the coordinates at the point, you know. So to give the coordinates, you have to get the x value and the y value at the point. You're starting with the knowledge that the y value is 0 at that point. And that is known. Once a point is on the x-axis, the y value is 0. So you have to use that information to help you to find the corresponding x value by then plugging that y value of 0 into the equation, and the equation will work and tell you what the corresponding x value is. That's all I'm doing. Plug in the y value in the equation. So the equation becomes 0, because the y is 0, equals negative 2x plus 8. So when I solve this for the x, I am finding the x value that corresponds to the y value being 0. I can do this 100 different ways, but I'm going to take this minus 2x, bring it on this side, make it positive. At the end of the day, I'm trying to make x a subject. So it's 2x equals this 8. And to make x a subject, I have to divide both sides by 2. Or shortcut, take this 2 and divide it under here. Anyway you want to look at it, you know that 2 times 4 is 8. So the x is equal to 4. So the point, because it asks for coordinates, you know. So you have to write these values now as a point. Put them in a point. So the answer is the point. 4 is the x value, 0 is the y value. That becomes the answer. Better? Yeah. You ask it over? Oh, all right. And then now, we come to here. So you're okay with this part? All right. Then now, we come down to here now. This part says, you have to draw that graph of Q. Draw the line Q. So actually I have 2 points that we can use. And oftentimes you only need 2 points to draw a line. And this question is helping. So you put those 2 points on the graph, use the ruler and draw the graph. So 1 point is 4, 0. Let's put it over here in blue, which is right here. The other point is 0, 8, which is right up here. So just use the ruler now and draw a straight line through them like that. And that's a line. But because I'm on this device and I can't use no ruler on it, I'm going to work out some other points using this gradient of -2 and find some other points. Remember, when the gradient is -2, look at this now. Or the gradient can help you. Now, remember, I know, but done already. You know, I can use my ruler now and just draw the line through that, you know, through those 2 points. You know. But I just want to get a little bit more accurate by putting in other points. So when the gradient is -2, -2 is same as -2/1. So to go between points, the gradient is what you can use to rise and run between points. So I'm going to rise -2 and run 1 to find other points. So starting from this point on the y-axis intercept, I can rise -2, run 1 to find other points. Rise -2 means I'm going to go down 2. So see it here, go down 2, run 1 to a point here. That's another point on the line. You can continue. Go down 2, that's rise -2, run 1. That's another point on the line. Then I can rise 2 again, -2, run 1. So this also is on the line. That's a point of intersection right now, you know. And then you see, if I continue, rise -2, run 1 again, I'm going to end up at that point anyway. All right. Now the only reason I did these points like this on this device is because I am not able to draw a straight line with this device. That's why I got these other points. I want to see exactly where the point's supposed to be. But then you could just draw a straight line through those points and label this line Q. And clearly, they must ask you about this point, that point of intersection. They must ask you something about it. That's all these questions are. This is the point where the 2 lines intersect. That point is 3, 2. That's what they're asking down here. See here? It says, complete the statement below. According to the graph, the solution of a system of equations of L and Q. You solve the equation of L and Q simultaneously. You're finding that point. So solution is just the point 3, 2. Right here. This is solution. See? Right the word solution here again. Solution. Solution. So let's see how I use how I got my answer. But go to that. Which question we doing next? Which question next? Which other question for? Come on. Huh? June 2021. All right. 2021 June. There you go. All right, so this page, you have that question over there. The part B is a different question. All right, the part B is a function. So let me bring up this on the screen and give you 6 minutes in it for this. You only need 5 minutes for this. You don't, it's 3 marks this question value, you know. 1, 4 marks. I'm giving you 4 minutes. You don't need 5 minutes to do this. Telling you, I'm giving you 5. So the question I asked you for that, the equation of this gradient of L, and then the equation of L. L2, equation of L2, write it here, so. So the next part 3, asking for the equation of L2. Let's write it so I can zoom up on the screen. Equation of L2 is the last question. Equation of L2. That's what this part is asking for, right? Nothing else for this line. 2 marks for that. All right, so this is the question you're doing now, guys. Put up on the screen here. That is it. Give enough 5 minutes. You only need 5 minutes enough. 4 minutes. All right, give you 5. Go. 5 minutes to answer that question. You want to do the part B though? Or does this part? Part B as well? Meet up over here in the meantime. Yeah. 2021, July 2021, question 4. Working on number 4s right now. Our question we do now are number 4s on the recent paper. To be number 5 on the older papers. Then on the right side of the screen is the part B. So if we finish the part A at the time, then you can do the part B, start the part B. I'll just give you the 2 parts to finish. Let's give you the 2 parts again. I'll give you another 4 minutes. Just do the 2 parts and done. So let me hear part A and part B. Part B on the right side of the screen. So I'm gonna change the time. I'll give you a couple more minutes. Add on, carried up to 6 minutes, right? That is it. Oh man, mess up. Oh. Go next. I'll do it. All right, let's do this. On the left side is a coordinate geometry. And again, they give it a graph. I mean, you don't have any coordinates, but you don't have any grid. But you can see that this point is the y-axis intercept -7. They give us that equation. Once you have the equation, you can put it in the standard form to get the gradient and the y-axis intercept by putting it in the standard form. All right? That's line 1 and line 2. All right, that's what I said now. It says express, see they're telling you to do it. Express the equation of line 1 in the form y equals mx plus c. That is so you can see the gradient and the y-axis intercept. They also told us that 2 lines are perpendicular. All right, that's information they gave us. All right, so putting this line in the form y equals mx plus c. Let's start. So it's x plus 2y equals 10. I need to get this x over this side. I'm going to put 2y equals minus x plus 10. But I want it to look like that. Then I need to get rid of this 2. Get rid of that 2. We can divide 2 by 2 or multiply 2 by half. Because I want to see the coefficient of the x squared by itself, I'm going to multiply by half. If you divide 2 by 2 is the same thing. At the end of the day, this becomes y equals minus half x plus 5. So we're going to have that line 1 is minus half, y-axis intercept is 5. So you know right now that the point 5, this is the point 0, 5 on the y-axis. All right, if you need it. But let's do the next part. The next part says you have to state the equation of line L1. So L1 now is this one. Remember now they tell us that they're perpendicular. No, L2 they say. State the gradient, my mistake. State the gradient of L1. So the gradient is this, minus half. Let me shift this over. This is for the next part. Just state it. The gradient is this. Let's call it M1. It's minus half. All right, and you should know that if you look at this line, it's gonna have a negative gradient. So you can't put a positive gradient for that on site. You don't make them kind of mistake there. It must have a negative gradient because it's sloping down from left to right. And this one must have a positive gradient. It's sloping up from left to right. So it must have a positive gradient. So you don't give a line that obviously has a positive gradient, you give it a negative gradient, and vice versa. We try to make them mistake. All right? The calculation of your diagrams must be consistent. Next down here now, just almost get the equation of line 2. All right, that's what's on the next page. That's the equation of this line. I'm going to do it right here in front of us. Now, we're trying to get the equation of this line. We already know the C is -5 on it. Although you yet know it's gradient. We know the C is already -5 on this line. But because it is perpendicular to the other line, remember the gradient of the first line is what? Minus a half, right? Gradient of line 2 is -1 over gradient of line 1 because they're perpendicular. This calculation is done by simply flipping this and changing the sign. So if you flip a half, it becomes 2 over 1, which is 2, and then change the sign to positive. So this calculation is going to become 2. We don't need to waste time. And so this equation is simply y equals this m times x, and this is the c, negative 5. That is the answer for the equation of line 2. But go to that, nice and easy. All right. So that finishes that question here. That's all I wanted. Next down here. Then we'll come to over here now, which is our functions. So this gives us two functions. That one and that one. This is what we call a rational function. Remember, this denominator cannot be 0. Cannot be 0. So if they ask you for the value of x, for which g is not defined, it will be that x plus 1 equals 0. It becomes undefined when x is 0. So it's when x equals minus 1. Minus 1 can't work on this function. So minus 1 cannot be in the domain of g. So sometimes they ask you stuff about that, especially when they give you that rational kind of function. What's question first one, f of 9. So it's a matter of plugging the 9 right here. So this becomes equal to a third times 9 plus 4. A third of 9 is 3. 3 plus 4 is 7. Nice and easy. Next part wants f of g of negative 3. Let me shift this down here. This is the next question on what that is. So to find f of g of negative 3, we can write this as f of g of negative 3. Meaning we're going to do the g of negative 3 first. You do the g of negative 3 by plugging the negative 3 in the g function. So that then becomes f of 3 times negative 3 over negative 3 plus 1. This inside here is the g of negative 3. That becomes negative 9 over negative 2. But I can say that negative 9 over negative 2 is the same as 9 over 2 because the negatives cancel. Right? 9 over 2. So we're actually now working out f of 9 over 2. If you like, you could put 4.5. The f of 9 over 2 now means I'm going to plug the 9 over 2 in the f function right there now to get the f of 9 over 2. Let me shift this over. Make some space. I tell you guys, CSEC don't give a lot of space to work, so you have to be very efficient with what you're doing. And that's why I encourage students to write the penciling. I actually encourage the use of pencil in exam with a clean eraser. But sometimes you have to just erase something. I don't have a lot of space to make a mistake. You make a mistake with a pen and cross out. You don't have to write it. Get me? You don't have to write, got the space small. And they give one additional page or two additional page on the exam paper at the back. If you keep crossing out and making mistake and use that, eventually that page will finish. Right? So I prefer write with pencil. Clean eraser. Buy a brand new clean eraser and a pencil. Dark pencil that dark enough that when you write with it, it's clear, you can see. But buy not dull pencil where you can't see. No joint pencil you use in a arm, in a TV. You draw a construction in it. You get a bright enough pencil. I sent it in the group. I sent a message yesterday about the type of pencil that you must get. Right. So you get a pencil, it's a clean eraser, you write and you test it. Make sure so when you erase it, you don't mess up the paper. Don't use a rubber on the top of your pencil. That not help you. You need a rubber by itself, an eraser by itself, a clean eraser, and a pencil. So when you make mistake with a question off a cross, erase it. And write the correct thing. You don't have a lot of space. If you make a mistake here, so you cross out, where do I put the word? Where? Go small spaces. I'm telling you. Because CSEC try to conserve on paper. So they make the spaces very small. They don't put a lot of paper for the exam. They be very efficient. I'm telling you, I tell students over the years, try to pencil. But a lot of my students try to pencil over the years. With a clean eraser. Make a mistake. Go on. But that aside, let me tell you one more thing. Let's tell you from now since you're on. If you do a question right? Unless you do it away and your brain is telling you that there's another way to do it. I'm not sure. I do it one way and get one answer. And say, no, I'm not sure about the answer, yeah. Sure about the way, yeah. But try it on different way. Try it another way, get a different answer. It's better you leave two of them on the paper. Don't worry about none. And anyone across out, even if it's right, they're not even looking at it. But if you leave both of them off the paper, they have to give you the benefit of the doubt. Once the correct thing is on the paper, they have to give you the benefit of the doubt. Once the correct thing is on the paper, they have to give you the marks. So it's better to leave two different answers, two different solutions on the paper. If you're not sure, rather than cross out one. Like cross out the right one and leave the wrong one, you're dead. Even though the right one is there, the fact that you cross it out, you have omitted it. They're not giving the marks for it. I'm telling you. Even them said right, you're not getting the marks for it. You cross out something, you avoid it. Get me? But when I prepare for exam like that, I prepare for example, do the right thing and move on. Because nobody has time to do no question 2 ways in the exam. Time is not provided for that. You get me? But I'm just telling you, come in a situation like that, whatever, don't cross out the word. Get me? But additionally, as I said, you see the tight space that they're giving it to work. If you make a mistake, you don't have a place to work. And you see that sometimes what you have to do is buy the space like this. Work over here, so and work over here, so complete everything. You get me? Because you just don't have enough space on these papers. And say you see these papers every day, you know how they are, get familiar with. All you have to just write small, put everything in there. You get me? And if you write too small, all the 60 mark the paper like this, scan the paper and send it to the markers. The actual paper don't go to the markers anymore. You know? That scan of your paper. That's why they tell you do not write outside these markings because they're gonna cut the paper here. You see these marks. You're gonna cut the paper along these marks and scan it. Right outside of the margin, you're not getting the mark. There's a shaded area that they tell you don't write over there at all. I think there's like over here, so see it? Do not write in that area. That area is going to be cut from the paper when they're ready to scan. So don't put nothing over there, son, because them never see. Get me? But rule of thumb, just fit your work within this space, within this part. Just try to fit your work in that little box right there. So try to fit everything you do within that space. So the cutters miss a little bit and go too wide. Because they're supposed to cut here, so you know, they're supposed to cut off right there. So if the cutter make a mistake, it shouldn't pass this. The cutter, if the man who cut the paper make a mistake and cut it too far, it shouldn't pass this. So get me? So be see if I'm fit your working inside of here. All right, good. The more things you know, the better. All right, I'm going to go back to the question. Right. So I'm going to continue up here. I'm going to do the F of thing now. Up here. So in the F of 9 over 4, 9 over 2, we're going to plug 9 over 2 in the F function. This one right here. So that becomes 1/3 and 9 over 2 plus 4. This becomes 3 over 2. This becomes 3 over 2. But 3 into this goes 1 time, 3 into this goes 3 times. It becomes 3 over 2 plus 4. 4 is the same as 8 over 2. 8 and 2 is 11 over 2 is the answer. 11 over 2. Y'all got that? I believe with decimal, you get 5.5. All right. Then down here now, it says determine the value of x for which g of x is equal to 5 over 2. All you have to do, put the g of x equals 5 over 2 and solve it. So the g of x, remember, is what again? Is 3x over x plus 1. So you're just going to put 3x over x plus 1 equals 5 over 2. And you're solving this for x. It's not complicated, guys. Cross multiply. You don't want these that you're trying to find to be dividing each other. So you cross multiply you know, to expand out everything into separate terms. Cross multiply. So it's like you basically taking this and multiply it up here by the 5, and taking this 2 and multiply it up here by the 3x. Cross multiply. I'm going to leave the x on it like that. This goes up there and that goes up there. So you expand it out into separate terms. So you can group the x values on one side. All right. So 2 times this 3x becomes 6x. 5 times this x plus 1. 5 times the x is 5x. 5 times the 1 is 5. This 5x comes over and subtract from the 6x. 6x minus 5x is x. X is equal to 5 is the answer. 5 is the answer. But go to that. That question done. Which one next? Who's at the door? Somebody's at the door. When you stop going like you know, little children, man. Not 2-year-old. 1 at 22 and 1 at 11. I'm going to the same age. You either go to female level, why you go down to this level? Huh? You know, miles apart in an age. And not the same exact way. Oh, that makes sense. Come on, man. And the big one, I'm tell the big one, try lead the younger one, then, man. The older ones lead the younger ones, then, man, and mature up. And stop act like 3-year-old in the class. I can't get serious. The exam this week, you know, and still can't get serious. One away from the day of the exam. You come and look nervous. And I try to get serious on the day of the exam. Too late on the day of the exam to get serious. But the foolishness to them, man. Because I never want to keep in class today, no. I'm upset from yesterday. No. But just come for the few people who really serious, you know. I now make the bad bunks, make the people who serious no benefit. Because for someone who no bother do nothing, I tell you. Don't get me upset today. Because I'm more for work to do, I sacrifice my time. And I delay my work. All right. Which question next? Which question on the next? No, 10:30. I want another half an hour. Finish off this thing. This question. If nobody knows the question, anybody online have any question 4 that they want to look at from the past papers? Question 4s from the recent papers. Huh? January 2016, that number 5 that. And the old paper is number 5. Let me see, January 2016.
Sir. Sir.
Yes?
Someone in the chat said January 2025.
January 2025, question number 4, or same like what she said a while ago.
Same question for I assume.
2025, 2025, question 4. Yeah, recent paper that is just gone there already. My brain said 2015 a while ago. January 2025, see it here, question 4. Here you go. All right, this is a full coordinate geometry question. All right, so the first part is on this page. Can we zoom it up and see what it's saying? This one asking you. This is straight calculation, this one. Part A and B. And over here is part C and D. The same question. All right, I'm giving you 8 minutes to do this. Don't need 10 minutes. Come on, you must can finish this in 8 minutes. 8 minutes. Start. Those are the two questions here. 4 parts. Make sure it says 4 parts. Yeah, question done. Let me see the question you want. June 2016. Sorry. I don't want everybody to come to class on Thursday. I know some of you might not come to the class in the week. They have other exams. But after the exam on Thursday, if you have an exam, I want to come here Thursday evening for the exam on Friday. I need to talk to you. I need to talk to you about the do's and don'ts on the exam day. Probably. Huh? No, we're there every evening. We can come every evening, same way to continue practicing. Every evening I'll be here. Tomorrow, Monday, Tuesday, Wednesday, Thursday. I'm saying some persons have exams, so they're not going to come. You understand? I'm saying even if you don't come, I want everybody to come Thursday. I want to talk to you on Thursday about what we do on Friday. Huh? About, Question 5, you said? Question 4 with the silver box. That's a yesterday question, but no problem, I'll do it still. That's a measurement question that we did yesterday. What did the measurement yesterday? That's actually a measurement question. So yesterday's question. I'll do it in the break. And the really is for correct question. Measurement, volume one, area analysis, like this. Solid geometry, like this.
Sir, there's no more parts to the question, right?
Yeah, you want to see success other people get doing that. That's where you go. You want the same success other people get full 48 hours get. We are miss 36 plus. All time. They are miss 38 hours out of 48. They get 10 out of 48. 10 out of 48. They get. In a sense. Man, I can't miss to catch them, man. Catch them. Catch them available. Can't drop the catch them. Ready. First part here gives us these 2 points. So we're going to have to calculate now. Right? We're not on the graph. It says calculate the midpoint between these 2 points. Remember, the midpoint is like an average point. It's quite simple. Treat a midpoint like an average point. It's the average of the x values and average of the y values. Simple as that. I'm going to call the midpoint capital M, so we can reference it. The average of the x values and the average of the y values. So to get average, you sum the x values and divide by 2. So it's minus 5 plus 7 over 2. And you sum the y values and divide by 2. 6 plus 2 divided by 2. Midpoint is an average point. It's in the middle. This becomes 2 over 2, which is 1. It becomes 8 over 2, which is 4. That is the answer, 1, 4. Nice and easy. Next part says, find the gradient of the line. The gradient is rise over run. Rise is the difference in the y values. Run is the difference in the x values. Common M for gradient. It is rise over run, which is the difference in the y values. Run is the difference in the x values. Plenty of people make the mistake and put the difference in the y values on top all the time. The important thing when you're taking the difference, you have to take the difference in the y and the difference in the x in the same direction. Very important. What do I mean by that? So I have these 2 points. These are my 2 y values. I have to take the difference off first. I can take the difference this way, or I can take the difference this way. If I choose to take the difference in the y values this way to start, when I'm taking the difference in the x values, I have to go this way as well. Get me? Whatever direction you take the difference in the y, you have to take the difference in x the same way. Why? Because gradient has a direction component in it. And so you have to take the difference in the y values and the difference in the x values the same way. So let me do it right and then copy it down. So difference in the y value, I'm going to do this point minus this point. I'm going to do 2 minus 6. That's the difference in my y values. I'm subtracting them this way. Because I subtract them that way, when I'm doing the difference in my x values, I have to subtract them the same way again. 7 minus, and that's a negative 5. 7 minus, and note now, I am subtracting a negative 5. Plenty people going to put 5 there and get it wrong enough. Wrong, you're subtracting a negative 5. You can bracket it or you can leave it without the bracket. It becomes a plus in any case. This becomes a plus. Minus becomes a plus. This therefore reduces to negative 4 over 12. Negative 4 over 12 is the same as minus a quarter. Minus a quarter. Minus 1 over 4. So divide the numerator and denominator by 1 over 3. Divide by 4. 1 over 3. So I'm going to move this down onto the next page now. That's my gradient down here. That is it. Minus a third is the gradient. And the most one the equation now. Can't get a coordinate geometry and ask for some equation. Let's see over this side now. Equation of something. All right, here now I want the equation of the perpendicular bisector. Remember now, the perpendicular bisector is as it says, bisects and it's perpendicular. Bisects means that it passes through the midpoint. We know what perpendicular means. That negative reciprocal gradient. So I'm going to sketch it out for you, just in case. So you have a visual of it. So it is like you have the line CD. So CD would have been. C is negative 5, 6, and this. So like the line CD is like this. That's CD. I'm just doing a schematic of it. The question is asking us for this line, right on the perpendicular bisector, passing through M, and it's perpendicular. So the question is asking us for that line that I'm going to call line 2. It's the second line I'm calling it line 2. So I'm trying to find the equation of that red line. That's the line that I'm trying to find. The perpendicular bisector. So to find the equation of that line, we need to know 2 things about it. We need the gradient of it and a point. The point is clearly this one. We have that point already. That point is 1, 4. That point right here is 1, 4. So what we need for this line now is a gradient. We don't have a gradient yet, but they're perpendicular. So the gradient of my line 2 is minus 1 over the gradient of CD. This over here was the gradient of CD. Where did we calculate it? Right here. That's the gradient of CD. Remember, this calculation is to flip the one that you have and change the sign. Right? So let me write over here. Gradient of CD is minus a third. So you flip minus a third and change the sign, going to become 3. So we're using this gradient and this point to get the equation. Some persons, they still use y equals mx plus c to do it. Plug these values inside here. And also this value here. And then calculate the c from that equation and then plug it back. Some persons do it that way. No problem. If you do it that way and get it right, good. No problem. But we can use a method where we use the point gradient form for the equation of a line, which is y minus the y value at the point that we know, which is m, equals the gradient of line 2 into x minus the x value at the point that we know. So plug in these coordinates and this gradient in this equation. I will get the equation straight by doing that. So it becomes y minus the y value at the point M is this 4 over there. So that's the y value at M, 4. The gradient of this perpendicular line is 3. Into x minus the x value at M is this 1 right there. 1. And so it's y minus 4 equals, expand this, we get 3x minus 3. This minus 4 comes over here, becomes a positive 4. Positive 4 minus 3 is 1. So this is y equals 3x plus 1. That is the answer for the red perpendicular bisector. Want to get that? Good. So we come down here and it says now, another line AB is parallel to CD. Now, if they're parallel, it means they have the same gradient. So the gradient of AB is now equal to the gradient of CD, which is now equal to minus a third. It's gradient of AB. But then this line now passes through that point. And that's an easy point. That's actually a y-axis intercept. Oh, we know, because the x value is 0. So this point is actually a C equals 1 point. So for this other line now, what is the equivalent line? You have the gradient and you have the C. So you're good to go. You use that. You don't have to use this format to do this one. You don't have to use this format to this one. You can go straight and use the y equals mx plus C now. You plug the values in there. Y equals minus a third x plus 1. 2 marks to do that, you know, easy. 2 marks to do that. 1 mark for recognize that the gradient is a third. 1 mark for recognize that that is the C. Question done? Yes. All right, what time is it? 10:51. We have time for one more. We'll start a little bit late. Start late. You want to start late for sure? So I say I do one more and then we'll take the break. Take the first break. And during the break, I take a couple other questions from persons or whatever during the break. So if somebody come on the morning and go to a question during the break, I'll be no problem. From any other topic. Not following during the session, following this order. So we're doing number 3 next. We have some other questions from other topics. I'm just run through during the half an hour break. As usual, no problem. All right. So Elizabeth have one which one I'm going to already. Single box question. Any other question? Anybody want to do? Online, anybody in our question 4? What anybody wants to do? No? All right.
Sir, can I find one?
Huh?
Sir, can you just
Yes,
find
sir.
one, sir?
Yes, sir. I have a question.
No, I'm not finding any. You don't find
Sir.
question. You find
Sir.
10,000 questions going already. I put the time now. Yes?
Did we do May, June 2023 already?
2023?
Yeah, May, June.
Which question?
4.
Question 4?
Yes, sir.
I think that's what we did first. What's up?
First. Oh, I joined a little late, so.
Yeah, you can watch the video. The video is there.
All right.
It's the first question we did. 2023. Question 4. See there? See there, so is it we did first? First question we did this one.
Okay, sir.
Yeah, so you can watch the video. You can watch it. You can actually watch the video on YouTube right now. Go back and play. That's what we started with. So nobody have any question. Nobody go. But okay. All right. I'm not putting up any question now, guys. Don't put up question. I've been giving you questions since September. It's your time now. And I can tell you all these questions you were giving me now to do, I gave you them already. Can tell you that for sure. Every single question I want to give you for do now. Me go to them already. I tell you now. Some go to them already. But on the brain, try. No remember. No remember or not forget. When I'm going to all them questions already, you know that though. Because I've given you all these past papers already to do. Every single one of them. I've given you all these past papers to do already. And we used to do these questions while we did the topics. So we did, for example, coordinate geometry, we did these questions in the Saturday session that a lot of you missed. And one of them, since we had the mock exams on the Saturdays, since March, we do all of them paper here. Just that someone used to get the one paper on the one paper, two papers are put on the table. One of them is supposed to do in the class and one or two. But smile, don't do the other one at home. So don't get those are the questions. But I give you all these questions already in this class. Tell you. Hey, if you don't follow my program to the T, you know, you're ready for exam. You're ready for exam when April done, you know. When April done, when the last of April come, you can do the exam. I tell you. Sure, I don't need no marathon or nothing. You can follow my program and set it out. You can do the exam first of April. Yes?
We could move the clock, so I'm gonna see the answer for the one coming come.
Huh?
I'm asking if you could move the clock because I can't see the question. Because I just come
This was from this morning. Oh, the one to see the solution?
Yes, sir. Come come.
All right, guys, we'll take the break now then. We'll take the break now. All right, so this is the first part of on the right side of the screen. That's the first part of the question.
Oh, yeah, remember doing this.
And this is the rest of it over here on the left side of the screen. All right, let me start the clock. Half an hour break, guys. 30 minutes break. Okay. And look here now, Mr. 30 minutes, I mean 30 minutes. Nobody foolishness today, no. Nobody foolishness today.
Sir, should we still stay in the Zoom?
Huh?
Should we still stay in the Zoom?
Yeah, we're not coming out.
Alright.
I'm gonna work a couple of questions. Gonna 18 question 4. All right. So in the break, but somebody wants to do a question for them. So we're gonna do a couple of questions. Still. You can go on a break, you know. Take on a break. Take your break. June 2018. Huh? No, discipline, man. Just you come for 11 o'clock class.
Yes, sir.
Huh?
Sir. I woke up at 9. My sister was ready to leave the house by 10.
Oh, wow.
It's not my fault, sir. It's not my fault.
Huh? No. One person is to come. Still question here. Oh, you still on here watching it? All right, see it here. This one, right? Is the functions part you want? It's a nice question. You have chosen a nice question. Yes, true, because this one a little bit different. This one a little bit different in that they give you a domain. A domain of just 3 values. What this means is that those are the only 3 values that are allowed to work in this function. That's what that means. When they give you a domain, means that you can't use any other x value on the function. That's in domain. So the function is restricted to those 3 values, and the range is going to be the 3 y values that they get from those 3 values. That's a nice question to choose. But this one has to be different from the rest. Get me? Let me show you what's happening there. For this function, I'm going to restrict the domain to this, right? If you were to do a mapping diagram for this question, it will be that you have a mapping. Let's say the domain is B. Let's just call the domain B, right? Let's just not the domain, the range. A mapping to B. And you will have 3 values in the domain. 1, 2, and 3. And the function that is doing the mapping is this. F of x is equal to that. So f of x on this function is half x minus 3. So you take the one and you plug it in here to to see what it maps onto. Half of 1 is what? Half, right? And half minus 3 is negative 2.5, right? This is negative 2.5. Let me make this a little bit wider. Negative 2.5. Then 2 is the next value that can work. Plug 2 in there. Half of 2 is 1. 1 minus 2 is negative 2. That's negative 2. And then 3. Plug 3 in there. You get minus 1.5. 3 over 2 minus 1.5. Minus 1.5. Minus. All right, let's put this. Minus 1.5. No, minus 1.5. It's plus 1.5. My mistake. Plus 1.5. We're going to get 1.5 minus 3. Give you minus 1.5. So those are these 3 values. That's your range, you know. These 3 values is the range. And if you complete the mapping, then this 1 is mapping to that. This 2 is mapping to that. This 3 is mapping to that. Those are your 3, that's a mapping diagram. These are the 3 values in the domain, the 3 values in your range. So the pairs of values on this function, you have to pair them up. It's this pair, which is 1, negative 2.5. This pair, which is negative 2, negative, no, it is 2, negative 2. And this pair, which is 3, negative 1.5. No, remember, what I'm doing now is not a part of the question. I'm just trying to give you some context. They can appreciate this one. So they have restricted the domain on this function. So those are the only values on this function now that are allowed. The only values that are allowed in the domain are these 3. And for those 3 domain values, these are your 3 range values. No other value can work. It can be no other domain value. It can be no other range value on this function. Right now, based on this definition. All right. We say we must find f of 1. So f of 1 will be the 2.5 over there, negative 2.5, right? So I would have plugged 1 into the function up here. And the f of 1 would have been half of 1 minus 3, which is minus 2.5. You can put minus 5 or 2 for 1. See? All right. Next part now says, find the value of x for which f of x is equal to 2. Watch this now, negative 2. This is talking about this x value now. Because you see, when the range, f of x is the range, is equal to negative 2. See here, when the range is negative 2, this is your x value, 2. The answer for this is actually 2. We can work it out. That's okay. If you put f of x equal negative 2, f of x is this. You put half x minus 3 equal negative 2. We're going to get carry this over, become positive 3. 3 minus 1 is 1. So you're going to get half x equals 1. And you multiply with 2, you get x equals 2. So this is bringing you back to this point. So the consistency of it, good. And then now, next part now says, an ordered pair of the function is expressed in the form AB. It says, using your answer in 1, 2, and 3, otherwise, list the ordered pairs. So we get the first ordered pair, which is the 1, sit here, the 1, negative 2.5 gives you this first ordered pair. I've written them out for you already, this one. Never realized I asked for them. Then the 2 here was the range coming from this x value. So these 2 combined to give you the next ordered pair, which is this one. But you have to know that there's a third ordered pair. That question didn't ask for yet, which is obtained by the 3. So you have to calculate f of 3 to get the next pair. And the f of 3 works out to be negative 1.5. So your ordered pairs are these these values. See, the ordered pair in the form AB. So the answer they're looking for is these 3 values. I'm going to copy them down. I don't have to write them over. So this is asking for these 3 values. like this question, a little bit different from the norm. Those are your ordered pairs. Get me? Let's go to the next part now. This question says, explain why f of x is not equal to 5 on this function. F of x is not equal to 5. What that mean? Because 5 is not in the range. I can split it another way. There's no value of x that is mapping onto 5. You understand? So to explain that, you could maybe draw the mapping diagram here, so. Or you put this set of order here, reference them. We can say there's no x value mapping onto 5. There's no x value that is in the domain that maps onto 5. You get me? And only one mark for it. So you can say there is no 5 in the range of f of x when the domain is 1, 2, 3. So that there's no 5 in the range. In other words, there's no x value that's going to give you a 5. Sure. Yeah, you understand me? Or another way to do it, you could solve for the x will give you 5 and say that x value is not in the domain. That's another way to do it. But I solve this and say which x value would I give you 5? And that x value is not 1, not 2, and not 3. And the domain values of the x value, this function must be 1, 2, or 3, based on this definition that they gave you right here. See? It's on this domain alone. So those are the only 3 values that can be allowed on this function. All right? That is it. Anything else? You want to do a part of two? All right. They go to the silver, nobody want to silver box question. The question they show me first, the 2015, the silver box, they link up for first. Huh? Oh, all right. 90 minutes left in, so time fly. Almost 10 minutes, more than 10 minutes gone out of the time. Let's explain this question. $2024. This is 2021, January, June. For me. Somebody was asking for this question yesterday, seabed question. Which question? No, see there. All right. The second one related to the first one. I said the cuboid solid below the same volume as the trapezoid above. Huh? So we have to work out the volume of it, right? Or they tell you the volume, you see. Or they told us the volume is this. The volume is that. Yeah, but the scale question. And actually ask up on scale which question? I'll say last time class teacher. You said that it's not very popular. You know, very popular again like the first time. I'm gonna look and see this one. All right, so the volume of this thing is 2886, right? The volume is 2886. The question wants us to find the H. But the volume will be length times width times height. But the height over here is still H, you know. Length times width times height is equal to this width. Just equate it and solve it. So the length, which is 30.6, times the width, which is 8.2, times the height, which is H, is equal to that volume, 2886. So if you want to find H, take them two here and divide it under there. Simple as that. So the H becomes 2886 divided by the 30.6 and the 8.2. Whatever this works out to is the answer.
Serious, 11.5.
11.1 centimeters. So that?
5.
Huh?
Five.
This one. All right, so the trapezoid gold bar is melted down and all the gold bars. Yes?
11.5.
11.5.
Yes, sir.
All right, the trapezoid gold bar is melted down. So it's 2886 cm cube. It's melted down and made into 6 identical spheres. Right? It says calculate for each sphere the radius of each sphere. So what we know? If it makes 6 spheres, then the volume of one sphere is divided by 6, don't it? That's all? Okay, we know that the volume of a sphere is all this information. The volume of one sphere is gonna be 2886 divided by 6. What work out to? Two 886 divided by 6. Huh? 481. 481 cm cube. So to get the radius now, you see to equate this formula for the volume of a sphere to this. So that, Jordan, that's the formula for the volume of one sphere. No? So to get the R of the sphere, equate that formula to this. What you know is the volume of the sphere. So it means that over 3 pi r cubed, which will be the volume of one sphere, is equal to 481. And solving that for the R now. It's a must take pi is 20/7 this question. Yeah, 20/7. You see, to simplify this now for R. This pi is 20/7. All right, so it becomes 4 times 22 over 3 times 7 times r cubed equals 481. This is the 20/7. All right, so that's 88 over 21. 88 over 21 r cubed equal to 481. I take this 21 and multiply it up here. Let's eat it and divide it under here. And then get rid of this cube, we're gonna cube root. Let's look at it. So we're gonna have r squared, r cubed, sorry, equals 481 times 21 over the 88. Let's get rid of this cube, we're gonna cube root both sides. Cube root this side and cube root that side. This cube root becomes an r. Put r in front here. And then you work this out and you have the answer what r is. So that cube root of that expression gives you r. 88 there. 88. How much? 4.85. It's cube root there. Centimeter. All right. Next part now said the surface area of a sphere. Surface area of one sphere. Let's say each sphere now meaning one. Surface area formula is just this. 4 pi r squared. So that area of a sphere becomes 4 times 5, which is 10⁻⁷, times this radius squared. 4.87, 4.85 squared. That gives you the area, and you put answer in centimeters squared. What that one work out? 4 times 10⁻⁷ times 4.8 squared.
So but the better view is 4.86.
Huh?
Yes, I better view is 4.86.
You get 4.86.
Yeah, I say better view is 4.86 for the
4.8 is 4.85. There's no material difference there, so that's all right.
all right.
To what? 295 by 296.
Yes, sir, 296.
Yeah, it's really just around up to 4.86 here. So I was correct about it, right? It's already 4.86. It's 4.86. This is more 297. This is more 297. Yeah, Elizabeth, you have to correct this. And you get 4.85999. You have to change this to 4.86. Do the right thing. Huh? Why? Because I use the 6. 4.86 here so instead. Because we had 4.85, but the better answer is 4.86. So it's 4. I change this to 4.86. Like this. And so this is a better answer. Put this in the calculator and you get that. Yeah. I think they want to have map question. No, we can't find a map question. Maybe they want a map. One of the map question, map and scale. Map question was up on 2014, 2015. Move on 2015, 2016. 2016. Ah, uh, I did that one fire. Actually, I keep it on. It's time. That's all. Let's do question. Stop, what's it? Okay, now. Ready. Sorry, I'm 21. Sorry, I'm 21. Answer the question. Yes, actually, yes, yes, thank you. Stop back. 10 minutes, 10 minutes. 10 minutes for this question. So I'm doing this question. You know, wanted a measurement question. No, a scale and map question. 10 minutes to do that. 2015. In the final field. Elizabeth found it for you. 2015. Question 5. May 2015. Trust me, you really only need to see one map and scale to stand with. One of them are see. But you must scale back for distance, you must scale back here. And you wrote it. Remember, you do the scale just stand just like with the ratio. Ratio is multiply the ratio up and down to get the information that you want. Simple as that. So the map pass here just allow you to reach.
Yes.
Do the best there. You know? So yeah, baby. Yeah. Just stay there and do all them something, and when I come over here and do something. No, you come class, come do all them foolish. Stay home, man. If you have to wait the time. Who win the Premier League? Where's Manu on the list? Where's Manu on the list? Map. I don't know. We don't want to watch it. What's that? A map? That's called a map? Yeah, that's a map. What is that? It's a map, it's a map as in map. Which paper are you doing? Martin, which paper are you doing? 22? Huh? 5 or 8? Hey, somebody play music. What that? Huh? I'm touch it. Turn off that now. Music, do music. Ready, let's go. Alrighty. First part over here is just some skill conversion. It says a car is traveling at 54 kilometers per hour. Calculate the distance it will go in. What's happening here? Calculate the distance it will go or cover in 2.25 hours. All this means is that it goes 54 kilometers in 1 hour. That's all this means. 54 kilometers per hour means it go 54 kilometers in 1 hour. So if you want to know how far it will go in 2 hours quarter, 2.25, just need to multiply this now by the 2.25. Simple. That distance is equal to 2.25, which is 2.25. 2.25 times 54 kilometers. That's the distance it will go. But understand that? But this is actually 2.25, right? What is your work out to?
121.5.
Good. This one says, calculate the time in seconds it takes to cover 250 meters. Given that 1 kilometer per hour is 15/8 meters per second. I don't even have to do this, you know. You want the time it takes to go 315 meters, right? I can use this same ratio and work to get my 315 meters from that ratio. Not so much marks for this time, 2 marks. You can convert it and all of that, but you can actually get it from this. Convert kilometers to meters and convert the time to seconds, and then make the distance come down to 315. Can do it that way. Rather than convert to meters per second first. You can also convert to meters per second first, yes. And then do 315. Right? But it's 15. If 1 kilometer per hour is this, then we can multiply this by 54 to know the speed in meters per second. Get me? And then now we can know how long it will take to travel 350 meters from that. Because the speed equal the distance over the time. So whichever way you want to do it, which one do you want to do? Want to do it both ways?
Conversion.
All right, somebody's a conversion. So if this is that, then we can multiply this by 54. So we can say, therefore, 54 kilometers per hour equals, multiply this by 54, what do you get? Multiply this by 54, what do you get? Multiply this ratio by 54. Taking this out, multiply it by 54. You see what 54 is in meters per
14.5 minutes.
I'm getting 15 meters per second.
Same, I get 15.
Yeah, 15 meters per second. So this now means that it goes 15 meters in 1 second. That's what this means. So to know the time, you can divide this number by 15 to know how many seconds you get. But understand that? But I go to that. If it was 15 minutes in 1 second, you want to know how many 15 minutes in that. But each of them is 1 second. So the time that it's gonna take becomes 315 over 15. That's the number.
21, sir.
21 minutes, sir.
Seconds, 21 seconds.
Second, bro, second.
The time in seconds, 21 seconds. That's it. We're gonna leave it at that. We're gonna leave it at that. Down here says, write this in a ratio 1 to something. Now notice there's no unit on these. So you basically want to bring the two sides to the same unit. Remember, a ratio can be multiplied or divided by any constant value or any constant unit. Whatever equal here, it really should be a ratio. really should be a ratio. It is not true that 1 millimeter is 1 meter. So this really should be a ratio. These are ratios. So what it is, they want this side to become millimeter. All right? So 1 millimeter to 1 meter is 100 centimeter, don't it? As 1,000 millimeter, don't it? So 1 meter is 1,000 millimeters because it's 100 centimeter, which is 100 millimeters. 1,000 millimeters. They can drop the millimeters, and so it's 1 to 1,000. So in this case, x is 1,000. What good?
Yes, sir.
Here, this is 2 to 6. Not 2 each centimeter equals 6 meters. Same thing, 2 to 6. So first thing I can divide 2 by 2. I make it 1 centimeter to 3 meters. But 3 meters is 300 centimeters. Remember, 100 centimeters a meter, right? So this is 1 centimeter to 300 centimeter. Then you can divide by the centimeter and then get 1 to 300. That is the answer. Nice and easy. We'll come to this question over here now. All right. So I think this is the only map and scale we're going to end up doing for the day. So pay attention. Just in case you get a map and scale on your exam paper. This one says, the map shown on the grid of 1 centimeter square PQRS, a 4 tracking station. The scale of the map is 1 to 2,000. What this means, I'm talking, pay attention. What this means is that 1 centimeter, see your map to actual is 1 centimeter to 2,000 centimeter. That's what it means, you know. 1 centimeter on the map is 2,000 centimeter on the actual. That's what this scale means. But on land, you don't measure distances in centimeters. You measure it either in meters or in kilometers. When do you use meters? You use meters when you're using a small land space, like for example, on the school property. You measure distances on the school property, meters. If you measure in property like in the city of Kingston, you measure distances in kilometers. You get me? So this is maybe a map of a piece of property. So we measure distances in meters. So you want to convert this 200 centimeters to meters. This is the scale in meters. Additionally, the question might ask you questions in meters. Let's see. This is centimeters right now. Centimeters again. Something you're asking in kilometers. So you still need kilometers as well. And then this one asking for the area in meters, 30 meters squared. So we're going to have to work the 2 units. Let me deal with the scale first, or you convert the scale that they give you so that you're showing how you go from the map to meters on the land or to kilometers on the land, and also how you go to area. Just stopping to do that. No, that is the only question I'm going to do with map and scale. I don't think any recent examples have any of these. All right, so I must deal with that right now. So I'm gonna do it down here. So the scale that they gave us, guys, was 1 to 2,000. I will say that that means 1 centimeter on the map to 2,000 centimeters actual. So this is map to actual. So we're talking. But this scale is for distance. This that they gave us is for distance. Very important. That this is for distance. Wrong color. So we always give it a scale for distance. As I said, on the actual land, first off, you read it up on the phone and play a game in a class. Mommy, faster on the phone, class, playing games. I talk about that now, say no game, madam. When you see it, and yesterday I tell me, say, ask me if I come today. Yesterday I tell you, nobody come. Because you're a joke. And you ask me if you come, I'm sitting now. I tell you no, not joker. Not ready for the set. Not ready for the set. Anyway, so I want to see what the actual distance on the map would be, either meters or kilometers. So I'm going to convert the scale. So it's 1 centimeter on the map. To go from centimeter to meter, divide by 100, because 100 centimeter make a meter. So it's 2,000 centimeter would actually be 20 meters. So this would be the scale for distance in meters. If you want the scale for distance if you want the scale for area, you just square this. Remember now, this is for distance. This is for distance in meters. If you want area in meters, all you have to do is square the values on this. Because remember, area is like you multiply a 1 centimeter on the map by a 1 centimeter on the map to get an area of 1 centimeter squared. Is that 1 centimeter here where you multiply upon the map? It's actually 20 meters on the land. Is that 1 centimeter here on the map? Is another 20 meters on the land. So that area on the land is 20 times 20 meters squared. You understand that? So that's why the simple way to do it is just square the distance scale to get the area scale. All right? So to get the area scale, square this. I'm going to get 1 centimeter squared, because 1 times 1 is 1. So we have 1 centimeter squared. And square that, you're going to get 400 meters squared. So if you're working in area, in meters, from map to scale, from map to actual, you work with this for area, and you work with this for distance, working in meters. Let's say we want to work, so this is in meters. This right here is in meters. If you want to work in kilometers, then I need to convert this now to kilometers by divide by 1,000. 1,000 meters is a kilometer. So to go from meters to kilometers, you divide by 1,000. So continuing now to get a scale for in kilometers. Distance again, this was for area. Distance again. Starting back from right here. So I'm going to go from a centimeters to meter first by divide by 100. Then I'm going to start back at the 1 centimeter to 20 meters and then divide by 1,000 to get 1 centimeter. That 20 meters is 1, 2, 3. 0.02 kilometers. That's what this is in distance, in kilometers. So if you do that question and you want distance in kilometers, you're going to use this scale if you want a distance in kilometers. Divide the meters by 1,000. And then now, if you want the area in kilometers squared again, square this. You want the area in kilometers squared. Square the distance scale to get the area scale. Simple as that. So if you're going to work in area, and you happen to be working in kilometers, then you have to square both sides of that. Then to be 1 centimeter squared. When you square this, you're going to get 0.0004 kilometers squared. Check that for me. That's what they're gonna get. Kilometers squared. So if you're working in kilometers squared for area, and this question that starts with a scale of this, that's what I think. Now, if you get another question where the scale is different, You're gonna be doing the same thing with those different values. Get me? So you write the scale that they give you firstly by putting in the centimeters, because the map side will always be in centimeters, guys. Distances on a map is gonna be in centimeters. A map is just a piece of paper on the table. It's not gonna work in meters or kilometers on the actual map. So distance on the map on a piece of paper will always be in centimeters. And then if you go on a land space, like a piece of property, even the national stadium, a property as big as the national stadium, you're gonna be working in meters, distances in meters. Then if you go out to a larger area, now, like the city of Kingston, or you're going on an island of Jamaica, distances now between the places, they're gonna state them in kilometers. You get me? But the map side will always be centimeters. All right? That is it. So that's how you go from distance scale to area scale. Simple as that. Back to this question now. So I just digressed a little bit a while ago just to show you how you get the scale and how you use up the scale. All right, so this question gave us this scale right here. And this question said, determine in centimeters the distance in QR on the map. So this map that says a 1 centimeter grid. That's what they said, you know, 1 centimeter grid. I don't want the distance here, so just count it off. 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, 6 centimeters. So distance on the map for this is 6 centimeters, QR. 6 centimeters. What got that? Determined by counting squares in square centimeters, in centimeters squared, that's what it means, square centimeters. The area they want of PQRS on the map. I'm going to count squares. This thing form out a trapezium, obviously. Don't it? No, people feel like when they say count squares, they have actually count the actual squares them in there. No. I am counting squares to get what this length is. Look. 1, 2, 3, 4. I counted those squares to know that this side is 4. 1, 2, 3, 4, 5, 6. I counted those squares to know that this side is 6. 1, 2, 3. I counted those squares to know that this side is 3. This thing has the shape of a trapezium. So the area, I can use those dimensions. These are the parallel sides. This is the distance between them. Area of a trapezium is half the sum of the parallel sides times the distance between them. I counted squares to get those distances that I'm using. So the area on the map becomes half the 6 plus the 3, those are the parallel sides, times the 4 between them. Half of this 4 is 2. 2 times this 9 is 18. That's 18 centimeters squared. That is the area of that map right now. Next part says, let me erase this because it's on the next page. It says, calculate the actual distance in kilometers. So I have to use a kilometer scale that we found between Q and R. Q and R is the same distance. So remember now, the scale that we got for kilometers down here was this one. Right? So we got that one, right? So let me copy this back up. Let's copy it back up here for the working out. So this is what we got. And this started out by saying 1 centimeter to 2,000 centimeters. They divide the centimeters by 100 to get the meters. They divide the meters by 1,000 to get the kilometers. We want this now to become 6 Remember, QR is 6. So all I need to do for this to become 6, and then you see what that is multiply this ratio now by 6. Remember, the distance we want is for 6 centimeters. I'm talking. So multiply that by 6, this becomes 6 centimeters on the map. That's what QR is. Multiply this by 6, we get what? 0.6212,
0.12, sir.
kilometers. And this is the answer right here. This thing is the answer that I wanted. The actual distance in kilometers, using the kilometer distance scale. 10-year-old, relax. Pay attention, man. Relax and pay attention. So I go back to prep school. Let's continue. Can I get the actual area now in meters squared? So you're going to have to use the area scale. The meters squared area scale. So we're using back now this calculation here that we did. We'll copy it back up here so again, just to have it on the part of the solution. So it's this that we did, all of this. So this is what you'd have to do in this question. Get the area scale from the distance scale by squaring the distance scale. That's all you have to do. Square the distance scale to get the area scale. And then after the area scale, you want the area. Remember the actual area was 18 up here. So all you have to do now is multiply this area scale in meters by 80. All we have to do. We're going to multiply now by 18. Such that this area on the map becomes 18 centimeters squared. So you're going to get that 18 centimeters squared, which is the area of PQRS, equal. Multiply it by 18. Then want to get how much?
7,200.
7,200 meters squared. This is the answer. Very good.
Yes,
You
sir.
don't do anything more on these questions. A question like this. That is it. All right. You won't need to do anything more on this question. Go from distance scale to area scale. That is all right. By squaring the distance scale. Remember, the distance on the map is always in centimeters, but distance on the land can be meters or kilometers. But the original scale that they give you centimeters to centimeters. Convert the actual side to meters by divided by 100, and then divide by 1,000 to get it in kilometers. So then you know what 1 centimeter on the map is. But meters or kilometers on the actual land. So on area, just square those numbers. Square those numbers they have. That is it. All right. We're doing number 3s, guys. We're doing number 3s. So ready, you tell me which question we're doing next. That is one finish now. Tell me a question 3 that you all want to do now. Ready? January 2024, question 3, he says. January 2024, question 3. They have 3A, you have 3B. And they have 3C. You want all of it? Huh? Just A you want? Construction. Okay. So I have to bring up the project, the thing then. So, all right. So you have the instruments here?
Wait, sir, you can do C too.
You want to see it? All right, no problem. Think up on the next slide. Give me a couple of minutes to do it for yourselves. January 2025. No, it's 2024, sorry, 2024. All right, somebody wants C. C is transformation. C is transformation, the one that you have to construct. Comes in question 3 on the exam paper. All right, so see here, so. All right, those are the 2 questions. 10 minutes. 10 minutes. This one is describe P onto R. And I'm going to zoom up here, so answer the next part. And I also want you to do R onto Q. So part 2 is R onto Q. R onto Q. Describe those 2 transformations in this diagram. And then over here, doing that question, that construction right there. Measure anything? All right, let's start the clock. 10 minutes. I want a transformation that moves P onto R, and one that moves R onto Q. 10 minutes. The January 2024 paper for the group. It's the next part there. Take 10 minutes to that part there. Come on, man. Move so slow. Easy stairs. I describe it transformation. Nah. Easy to describe. Easy. You can't fast. That time finish. We just have to describe it. Who finish? General finish. General finish. Hey. Yeah. Who was ordering today? Huh? Huh? Safety. The delivering. The delivering. So everything is cool. So I start on the next question, you know, after this. Start working and finally the next question, you let go on. Question 3, which here? PQR.
Sir, are there any more matrix questions?
Huh?
Is there another matrix question?
Question 3 is
Yeah, no. The part C. Is it just
matrix is question 10.
sir, may I ask the matrix transformation if there's more questions on it on this paper?
Yeah, well, it'll be question 10, which we did yesterday.
Oh, alright, okay.
The matrix transformation comes from question 10. The question 3 matrix transformation is some construction. They don't really bring the matrices type here too much. Ready? Which one said? 2022. All right, guys, let's do this. This side first. So the question here tells you that they want triangle ABC. AC must be 8. Right here. And BC must be 5. I must construct it with a ruler and compass only. And we can see they give us the line AB to start. So C is somewhere up here, so. The AC, you know, is 8. So this line must be 8. And this line up here must be 5. So how do we get the right line? The right point up here? What you know is that C is on an arc that is 8 centimeters from here. So we have to draw an arc that is 8 centimeters from here. And then now, from here, you have to draw an arc that is 5 centimeters from here. 5 centimeter arc. Where those two arcs meet, somewhere here, it's going to be 8 from this. And at the same time, 5 from this. That's all they need, an 8 centimeter arc and a 5 centimeter arc from A and B respectively. So let's do it with my device over here. Let's see. Let's see. We're supposed to have my construction thing somewhere there. There you go. All right, so I'm just going to draw a line. I don't know the actual length of that line. So I'm just going to draw a line and say, all right, this is the AB. All right, I'm just going to say that that is the line AB. Over here is A. Over here is B. I'm going to use that instrument as a compass. And I'm going to get the 8 centimeters. So to make sure you get the 8 centimeters, I can bring out the ruler and put one end of it, the point at 0. Open it up to 8. Measure the 8 on the ruler. lock it, put away the roller. Let's make the construction a different color. Come to this end at A, rotate up somewhere up here, note, and make that arc. Everywhere on that arc is 8 centimeters from A. Then I need to do the same thing from the other end, but to start using 5 centimeters. So bring back the roller again. And I'm measuring from one end 0, again start from 0, put 1 point at 0. Then adjust the compass to 5. And then I lock it, put away the roller, come to the other end of the line, rotate up, and cross that. That is 5 centimeters. Where those two lines meet is a point C. 8 centimeters from A and 5 centimeters from B. Use a ruler now and complete it. So I have to do now. So join these 2 points with the ruler. Join these 2 points with the ruler. This is the point C. You can label it up. 5 centimeters, 8 centimeters. No, this was, oh, we don't know this. We don't know this. We don't know that. Scratch that. This is 5 centimeters. Question said now, we have to measure an angle. Measure angle BAC. We need that guy to measure the angle, or protractor. I measure an angle at A. So put the eye on the point. Rotate around. So the baseline pass through 0. Like this. And 0 must pass through 0. And they read in the 0 scale from B upwards. On this diagram, that angle that I'm looking at, make it a little smaller. That angle I'm looking at looks like 39 on this one. Measuring the 0 scale, the inner scale is the 0 scale. I'm getting 39 on this. But remember now, I do have the actual paper. And the actual paper might be different. Based on this that I drew, that will be 39 degrees. Well, you have the actual paper in the exam to be. You get me? Whatever distance you get, that will be it. Whatever angle you get, that will be it. That finishes that question there. Very good?
Yes, sir.
All right, good. We'll come to know the transformation question. It's a pretty easy question. All right, pretty easy question, this one. No sugar on this one. This one looks straightforward. It says the diagram below shows 3 triangles P, Q, and R. Triangle Q and R are images of P after it undergoes a double transformation. It said describe the single transformation that maps P to R. That is clearly a translation. There is no change in size and there's no turning. And there's no flipping around. The image and the object are exactly the same. They are just in 2 different positions. So all that happened is that it moved. Translation. And when you describe a translation, you need to state how many units left or right, how many is up and down. You only need to see what happened to 1 point. So I can use a convenient point to do it. And a convenient point to be right here. This point came to here. So there's a measure of how many units right and up it went. So come across here and then go up to here. These 2 points correspond to one another. So once I get the displacement, are the components, the movement, coordinates, the components, Left and right. So right is 2 units. Make sure this is actually 2 units. Yes, from 2 to 4 is 2 units. Because if this was 2 and this was 3, then this would be 1 unit. You get me? Even though it's 2 squared, it will be 1 unit. All right? So look at the scale of the graph. So this is actually 2 units to the right, this one. And then you're going up. So make sure again, each of these is 1, because it's 1 and then 2. So going up, you go 1, 2, 3, 4 units up. That's a translation 2, 4. 2 units to the right and 4 units up. And by if it was a case where it went down, then this would have been negative. If it was a case where it went to the left, then this would have been negative. You get me? So the right is positive, up is positive, to the left is negative, down is negative. That's a translation, 2 units to the right, 4 units up. Or you can actually state this translation matrix. And so you can say, it's a translation given by that, and they'll accept it. 2, 4. All right? But I'm going to spell it out and say it's a translation. I put the word translation. You can't just say it's a translation. We give you components. So I want to say a translation. Two units to the right and 4 units upward, given by 2, 4. I give them everything. Give them the word and the matrix. The translation and the matrix. Then I want to know you go from R to Q now. Look, from P to Q now,
Yes,
from R
sir.
to Q. Yes?
You can't just say translation and you just give them the vector.
Yeah, man, I think if I give them this, they give it a marks. That's just they're not listening. I said it, you know, because the translation tell them that, they give it a marks.
Oh, all right, thanks.
You get me? But we kind of like play it safe and spell it out and everything, because English. But yeah, if it's a translation given by this, basically they have an obligation to give you a marks. Because they can give you a question to say, this is a translation, done. You have to know what that is. So you can give them back as an answer. All right, that is it. Now we want to know how you go from this one to this one. Now, clearly that is a what? That's a reflection.
Sir.
Now, remember now, we're going to start about this again. Oftentimes, a reflection, you might think is a rotation. So somebody might think it's a 180-degree rotation. Somebody might think, okay, this rotates onto that or something. Just, the mind just sometimes look at it and you might think it's a rotation. Oftentimes, a rotation looks like a reflection. A reflection looks like a rotation. To decipher which one it is, you can check the orientation, little girl. You can check the orientation. If the orientation is reversed, then you know you have a reflection in a line. Rotation does not reverse orientation. See there? If I rotate my hand, the thumb is on the right side, on this side all the time. No matter how much I'm going to rotate it through. But a reflection, if I reflect this hand, I'm going to get this hand. So the orientation is reversed. So how could I check orientation on this diagram that did not give me any vertices? They didn't name the vertices. Just name them yourself. Name them yourself. So I would name them myself just to check it. I'm not going to. I know the reflection, but I'm just showing you if you're in doubt what you need to do. So I name this, for example, A, B, C. You name the corresponding points over there, the same letters. I put the prime on there. So this one is this, clearly. This will be A prime. This one is this, clearly. That will be C prime. This one is this, clearly. This will be B prime. Check the orientation now. A to B to C and this one is anti-clockwise, but A to B to C and this one is the other way, clockwise. So you know you have a reflection, because rotation does not reverse orientation. Orientation is how the letters go around the object in alphabetical order. Check orientation that way. So the orientation is reversed. You know you have a reflection in a line. Reflection in a line is the only transformation that reverses orientation. So we know we have a reflection. We cannot describe a reflection without stating the mirror line. So to just say it's a reflection, you're not going to get the marks. Any transformation you're describing, you have to give the name of the transformation and the components of the transformation. Reflection has one component, which is the mirror line. State the mirror line. But I can't feel again no start. Rotation has three components: angle, direction, and center. Enlargement has two components: scale factor and center. Translation has two components: how many units left or right, how many units up or down. You have to state these things as a part of your description. So the word fully there in the description, fully. Fully means you give the name and the component. That's how you describe it. Name and component. So we're describing a reflection now. We need the mirror line for this. The mirror line is halfway between the points. So the mirror line is a halfway mark between these 2 points. The mirror line is on here, and halfway between these 2 points, which is on here. So you have it already. Halfway between these 2 points is on here. So the mirror line is on those 3 red marks, which you could obviously see it, I know, but I'm just going through the process. And then you give them the equation of that line. And that line is a vertical line passing through 1. And so it is x equals 1. Not y equals 1, x equals 1. The vertical lines will have the same equation as the y-axis. Your y-axis is x equals 0. Equation of the y-axis is x equals 0. So lines that have vertical like the y-axis carry the same kind of equation. X equals a number. Horizontal lines, just to mention, is a line of the form y equals some number, like y equals b. Because remember, the x-axis is a line y equals 0. So horizontal lines carry the same kind of equation. Hey, touch a young citizen. You come and sleep in on the AC. Outside, go take heat, man. Stop sleeping. Come class, and want to get comfortable. Just sleep outside, my boss. Don't want to sleep inside here. Come for no work, you know. You better ask him to come. Come for no work. They're describing it now. Reflection in a line, x equals 1. Simple as that. A reflection in the line, x equals 1. That's equal to the mirror line. All right, which question somebody said, well, go 2022, they say? Sleeping starting, oh, go on, sleeping contagious. What's your young self for me then? What man? Sleeping contagious. And then I don't know, remember, we couldn't do work first idea, and I'm in a bother no money now. Which question say you want to look at? Huh? I'm stop a foolish this man, I'm not bother keep a class. January 2022. A young man must have energy, man. And young and sleepy and droopy. So I'm told you. If you got a gym, take some vitamins. You know, take vitamin and still sleepy. You should not take the wrong vitamins. January 2022. Stop sleeping, man. Sleep too much. Want some work to do. Couldn't do a whole paper and all was sleep. Question 3. Which part of it you want? The 2-part question. You want the whole of it? All of it? Which part of it you want? Yeah, man, January 2022, this is right. That was A part of here, so And that's this B part down here, so. Which part you want? The B part? Or the B part you want? No, it's actually C this. The B is this the one, this diagram one? Or this diagram? All right. Come here to take a bite at the cherry. You want the C too? All right, somebody else want to C. All right, let me set it up now. B and C. January 2022. Giving you 10 minutes to do it. I'm gonna wake up. If you not get work for doing, still asleep. We're not doing if you never get no work at all. January 2022. All right. Da, 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 da. Rise up out your slumber, man. All right, so this is the B part right here. The last part says give the geometric reason why angle P is 77 degrees. This part answer, let me put it here. So why is well, let me write it here. So why is P 77 degrees? Let me write it here. So the next part is part 2.
71 degrees, sir.
Yeah, 71. Why is angle P equal to 71 degrees? And that geometry reason I want. All right, that's this question, this part right there. So, and you say you want the next part now, right? So you want down here, so she's down there. So she just right here. So you want all of this. 10 minutes. 5 minutes for each part. Not even 5 minutes for each part. Come on, let's go. 10 minutes. Starting now. 10 minutes. Put this right in the middle here. So. Go, 10 minutes. Answer those questions. Find angle Q, angle R on this diagram on the left. Then give the reason why angle P is 71 degrees. And then on the right, that those two triangles, and those are image triangles, and you have to find the object triangle. Somebody music loud in the class. 40. Bring your earpod cost. Come, do the question, do the question. Yeah, can come device on the exam. Can go internet. Go to rule our phone and find our phone and just let it know. One from example, I'll find it. Check know that. You know better, all right, cheap. Yeah. Go to example on device and pick them. On and because there's no idea about how practice to the math. Yeah, it's the exam. So, in a sense, practice all the exam is gonna move without device. So they go to the exam room, you're gonna the practice will use it all the time. And then an example in our comfortable, he's smart. Serious. What's that sort of rules, man? We learn our own, man. No device load in the class. None. Put the phone up yourself. Somebody calling on me here. And I said, no, no, Bob, no phone. You can't leave it on, but I put it from my desk now. Next year. No phone allowed in the class next year. Because we don't care for yourself. We're addicted. Huh? What? Remember that? Come in there. You mean you guys? You mean this group? Come here, retire. You want me dead? I'm dead on the same. Once me can, I will teach it. I'm my favorite thing to do, but don't not spoil it for me, make me fall out of love with teaching. If I get someone to stay in, me fall in love with it again. When I can't be the group, I fall out of love with maths now. Yeah, miss. Don't make me fall out of love with maths and teaching maths. Don't make me fall out of love with teaching maths, miss. So you have to get that one straight in. Please, please.
Sir. Sir. This is gonna end at 9 o'clock, right, sir?
Huh?
Sir, this is gonna end at 9 o'clock, right?
I don't know, my friends before that. I don't know.
Sir, because I wanted to prepare for English a bit, and then my French teacher is gonna have a Zoom too.
Yes, my friends before. Because some people same thing with some other person. So the other little question, I'm like, what are which question 2 and question 1? I don't think we need to spend 2 hours on those. So I might start the 1 hour session on the other topics after this. I'll finish early.
All right, sir.
Cool. But remember, we're working in the week, same here. During the week, we still have the evening sessions, come to practice every day.
Sir, what time are the evening sessions? You wanna know when?
Evening session, no, the evening session is from a class, it's not. Evening session is for the regular class.
Okay, sir.
We're gonna have more of this kind of session for the multiple choice, so you can look out for that.
All right, sir.
All right, time. I discussed down over here on the left. The diagram below shows 4 lines. 2 of the lines parallel. These were the arrows are the parallel ones. Once you have parallel lines, you have to be thinking about Z angles, your U angles, corresponding angles, your alternate angles. Well, I said Z angles already. Corresponding angles. You have to think about those things. Vertical opposite angles. What I mean by vertical opposite angles, like for example, these 2 lines that cross each other like this. These 2 angles are vertical opposites. That means that over here so is also P. All right. Alternate angles are along the parallel side. So you have this parallel sides, you come along this and then continue along the other parallel sides, you form alternate angles. So these 2 angles equal. They are alternate Z angles. Then corresponding angles are like, for example, like you have these 2 parallel lines. This line is what we call a transversal line because it crosses both of them, a transversal line. This angle makes the angle with that blue line. So it's going to make the same angle with this blue line up here. So those 2 angles are equal. They are corresponding angles, these 2. And then the U angles now, give an example of the U angles now. Like these 2 are U angles because you have this parallel line, and this parallel line, and they are joined at the same end with this transversal line. And so it looks like we have a U. That's what we call it, a U angle. The angles in here are what we call co-interior angles. We're going to call them U angles for short, but they are co-interior angles. The proper name for them is co-interior angles. And they add up to 180 degrees. So right now, the R and the Q add up to 180 degrees. Right, so those are some of the things to look out for in these diagrams. Let's answer the question, Joe. It says, determine the value of each of these. Angle Q, which is this one. All right. So for angle Q, and it also asks for angle R, right? For me, it is easier to calculate angle R. Quicker to calculate angle R for me because these two angles equal, are vertical opposite right now. So you're going to ask for Q first. That don't mean you have to calculate Q first. Right now, I see R first. And the fact is, R is going to help me to find Q. So I prefer to do it that way. I'm going to find the Q first. The R first, sorry. The R is 54. Notice I'm not putting the degree on it. Why? But the angle is R degrees. So the R is just a value of 54. All right? So the R is 54 because they are vertical opposite. They never ask for the reason, you know. They must ask for the angle 54. And then now, this angle Q, because this angle R, as I said, they are co-interior. They add up to 180. And so the Q is 180 minus the R. This Q is 180 minus the R, where the R is 54. So we're doing 180 minus 54 is how much? 126.
126.
So the Q is 126. Nice and easy. All right. Then down here now, it says explain why.
Wait, sir.
Yes.
You mentioned that R and Q are co-interior because of the parallel lines, sir. Why couldn't why couldn't Q and the angle, basically the angle above the 71, why couldn't they be co-interior angles as well, sir?
I mean, these two. These two.
Yes, yes.
Because this line and this line are not parallel. See that?
But they're running in the same direction though, and they're not
No.
touching.
Boss man. You have to have parallel lines to have these angles. You have to have parallel lines, you have Z angles, you have to have parallel lines, you have U angles. You have to have two parallel lines involved. So if I'm using this line, let me zoom it up. And this line and this line, there's only one line there. There are no parallel lines between these three right now. Look at it. Between these three lines right now that are involved with these two angles, these three lines that are involved with these two angles, none of them are parallel. Note it.
No, sir.
Good. This and this not parallel. If you just zoom in on those three lines that are marked blue, none of them are parallel. You cannot have alternate lines unless you have two parallel lines involved. You cannot have co-interior angles unless you have two parallel lines involved. You cannot have corresponding angles unless you have two parallel lines involved. And those three lines right now that I've marked, no parallel line are there. So them two angles here are not co-interior angles. Look here. When you have co-interior angles, the two lines that are joined at the bottom, these two lines would have to be parallel for them two angles in the base of the U, like you're forming a U, you know. This and this and this, like you're forming a U. So when you form the U, a part of the U and a part of the U must be parallel in order for the angles in the base of the U to be co-interior. Right now, those two, none of those lines are parallel that are involved in these two angles. You get it clear? You good with that?
Yes, sir.
Let me show you two co-interior angles. These two angles are co-interior. Because this line and this line parallel. Them two lines are parallel and they're joined down here. So this is a nice U. The leg here and the leg there parallel. So the two angles in the base of the U are co-interior. See that now?
Yes, sir.
So for it to have U angles, you have to have two parallel lines in there involved. For it to have Z angles, you have to have two parallel lines involved. Get me? All right. Good question.
Yes, sir.
Good question. Learn stuff from your accidents and learn. All right. So down here now it says, why is this angle? Why are these two angles equal? Because they are alternate angles. See? These two angles are Z angles. Sorry. They are Z angles, right? Because they come down this parallel one, go along the transversal, and continue along the next one in the same direction. That's the formula alternate angles, you know. Come down one parallel line, go across to the other one, and continue in the same direction. You form Z angles or alternate angles. So the reason why these two angles equal, because alternate angles, what we call Z angles. Are equal. That's why they're equal. Good? Better go to that. Come move to the next one now. All right. We'll take the whole screen. After this question gives us these two triangles, and they are images. I want to know they are images. I have the prime on them. Whoa. Jesus, how many people I thought again? 2022. Right here. Right. So these two are actually images. So this question did not show the object. I want to know the images because I have the prime on them. See it? That's the prime on them. So like this is the first image. That's a second image. So this question they have not given us the object. So I'm sure they're gonna have to put in the object. There's a man can come right on my desk, come sit down right by the table, professor. All right, so it gives those two triangles, the prime and the double prime triangles, X, Y, and Z, right? It says triangle XYZ is the image of triangle X. Triangle X prime, Y prime, Z prime is the image of triangle XYZ after an enlargement of scale factor 2 about the point 5.1. Draw the triangle XYZ, the object. So what means that? This is the result of an enlargement of scale factor 2. And I want us to show what the original one is. An enlargement took place from this point, 5.1. And we know that the scale factor of 2 would have doubled the size. So this right now is twice the size of the original one. So this side up here, for example, is 2 units. The original one is 1. This side down here says, 1, 2, 3, 4 units. The original one is 2. But what is important in this question to remember is that scale factor does not only affect the size on the object, it also affects the distance from the center of the enlargement. So I have to put in the center of the enlargement and kind of reverse construct this enlargement. You get me? Of scale factor 2. So we're going to put in the center of 5.1, which is right here. And we know that the enlargement took place out of this, out of those. Now what do we know? If the scale factor originally was 2, if you want, it can be 2 ways, you know. You can think of it as coming back to the image, you know, using a scale factor of half. Because the enlargement originally taken from the object to the image was a scale factor of 2. Then to go from the image back to the object, we can apply an enlargement of scale factor half to the same center. But then we can know, so okay, the distance was doubled. So we need to know what the original distance was by half in the distance. You get me? Let's do them one at a time. So out to Z first. This is the distance out to Z. You can put a ruler on it maybe, and then half it to see where the Z was. Or we can count off the component X and Y, horizontal and vertical. So I can measure this distance and this distance, and half them to see where half of this length is. This distance is 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. And then this distance is 2, half of 2 is 1. So I can come 4, 1 to 5 with the center. 1, 2, 3, 4. Go again. 1, 2, 3, 4, 1. So the center point, the original point is right here. But can I appreciate that? I'm halving the distance. I'm halving this distance, but I'm halving these components which are easier to count. So this whole distance across here was 4, and up here so was 2. So let's go, sorry, it was 8, 2. Half of 8, 2 is 4, 1. So half of this distance is here. It means that this point was here originally. You can do this with the same thing with other points. Like for example, you can do it at this point up here. So you can say, okay, break down 2 distances. So vertically up here and horizontally. Now half that distance. This was 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So I cut it in half and go 3, 3. You see where halfway is. 3, 3. So it's 1, 2, 3 to here. 1, 2, 3 to here. So this point is where this point was. You can draw it now, you know. This is your Z. This is your Y. We know that distance are cut in half, that length are cut in half, which is this length right here. So this right now is your original triangle. This is X. That's the XY. Cut those distances in half from the center of the line. Everybody say that? That is XYZ. XY. That is it, XYZ. Now I learn nothing. Pay attention, man. XYZ. But go to that. Cut the distance in half to bring it back to where the object was. All right? Because the scale factor was 2. So everything was doubled away. Half the distance back to 5 where it was. All right. Next question says, so we do that part. We construct, right? So let's finish this one. So I must draw that thing. Draw it. So we do that. Next part says, this is mapped onto that now. The prime is mapped onto the double prime by reflection on the line P, steady equation of the line P. So this is to find the mirror line that maps this to this. Easy. The mirror line is halfway between the points, right? So Y and Y prime, halfway between that is how much? This is 1, 2, 3, 4, 5, 6. Halfway is 3. 1, 2, 3, right here. That's the mirror line now. Can do another point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. That vertical line is a mirror line, for sure. And that's a vertical line, this blue vertical line is the mirror line that maps this to this. And the vertical line passing through 2. So that line is x equals 2. It is x equals 2. That's that vertical mirror line. What I go to that? X equals 2 the mirror line. X equals 2. So state the equation of the mirror line. This is it. X equals 2. But okay with that? Easy question.
Yes, sir.
Not too much. Which are we doing next? What time is it now? Oh, 5. I'm supposed to stop. Hold on. Got to have to stop now. I had one purpose supposed to stop. Come on, which one are we doing next? Let me decide if we are starting. We're supposed to stop 1:30. We stop, which question we want the next? Which number 3 you want the next? Because you don't want to stop and not say no. No, no. Huh? Must be January. Yeah, I've been at the time. You don't do the June one yet. Has to be January. When 25 question 3. Which part one? A or the B? A. Don't need B. Just A. All right. Recording, I don't understand. Working with you today. You guys taking the lead today. (2025) January. Oh, this already. Already. Let's try. So. This one already. Same one, let's press. The second one I want. Second one, Mr. Shaw. That one. I need 10 minutes for this now. 2025. This question part. I need 10 minutes for this. I need about 4 minutes for this. Come on. Huh? No, A and B? Somebody who asked for it only wanted A. Want B too? Do A first. Come. 4 minutes for A. Let's go. 4 minutes for A. Four minutes for A. We go back right here. Breaking after this, half an hour. I'll come back at nobody. Question tools. Huh? Only 1 hour question tools in one. What now? Three topics we have left, 3 questions we have left to do now. Question 3 now, right? That is the question 2, question 1, and question 7. But someone wrote question 7 yesterday now. You have 1, 2, and 7. 7 is the pattern question. The question 1, 2. After this break, we have question 2, question 1, and question 7. So for those 3 topics, we want to cut the time to hour and a half. No problem. So we'll finish earlier. Up to you guys still. All right. I reach the easy question them now. Although the whole question, I like question easy, but you know what I mean. I know some people have problems with the consumer arithmetic in question 1. You know, people have problem with consumer arithmetic, and consumer arithmetic is money where we live every day. Live and spend money every day. I mean, still have no problem with consumer arithmetic, you know, kind of love spend. It means, you're not a mess. But I come class, right now. Mr. Bring your earpod, come give me boy. Anyway, let's go. This question gives us this diagram up here. And the diagram below shows a regular hexagon. And the size is 8. Now, important thing is that it is regular. All sides equal, all angles equal. So all these angles in here are the same. And all these lengths, all the sides are the same. All of them are 8. They're all 8. All right? Question says, show that angle PQL, that's the angle inside here, that's one of the angles in here, is 120 degrees. So there are 2 ways that come to mind to do it. You can find what the total interior angle is for this 6-sided shape, and then divide that total angle by 6, because all angles are the same. Or you can find out what one exterior angle is, and then you know that the interior angle is 180 minus the exterior angle. Why would I use that approach? Because I know that regardless of the number of sides, the total exterior angle will always be 360 degrees. So the exterior angle for one exterior angle is going to be 360 divided by 6, which is 60 degrees. If an exterior angle is 60 degrees, then the interior angle is 120. To me, that's the quickest, easiest way to do it. You get me? So that is it. So let me show you what I mean. They're asking us for this angle inside here. Well, I know all of them are the same. They're all the same. The focus is on that one. I'm saying what we can do, we do question quickly, is to extend this side and find this exterior angle first. Exterior angle is always formed with extension of a side to the adjacent side. So extend this side and then complete the angle with this side that would follow it, the adjacent side. So that's an exterior angle. These 2 angles are up to 180. So if you know this one, 180 minus that one gives you this one. Total exterior angle is 360. They are all the same. All exterior angles are the same. So each exterior angle is 360 divided by 6, but there are 6 of them. We have 1 here, so 2, 1 here, so, 1 here, so, 1 here, so, or 1 here, so. Those are the 6 exterior angles. They are all the same. Because the thing regular. Once it's regular, all sides equal, all angles equal. So let's say I'm calling this angle theta and call it this angle in here alpha. So we can reference them. Right? I would say 6 times theta is equal to 360 degrees. Like theta is an exterior angle. And there are 6 of them. They're all the same. Even though we only show one from the diagram, there are 6 of them. Want to show the rest of them? Extend this and this a theta 2. Extend this a theta 2. Extend this a theta 2. And you just go around like that. Extend this a theta 2. Extend this now, this a theta. 6 of them, they're all the same. Total exterior angle is always 360, right? So it's a total exterior angle equals 360 degrees. Even for a triangle, total exterior angle of a triangle is 360 degrees. Even though the total interior angle is just 180, total exterior angle is 360. No matter the polygon you have, if the polygon have 1 million sides, the total exterior angle is 360 degrees. So that is it. Then now you divide by 6 of theta equals 120 degrees, equals 60 degrees, sorry. Then now the angle that you want, the alpha, is 180 degrees minus this 60 degrees right here, which is 120 degrees. To me, that's the quickest way to do it. Nice and easy. But let's do it the other way as well. By finding the total interior angle and then divide it by 6. So the total interior angle is n minus 2 triangles equals n minus 2 triangles. A polygon can be divided into n minus 2 triangles. And each triangle is 180 degrees. So that's the formula that gives the total interior angle. This n right now is 6. 6 minus 2 triangles. That's 4 times 180, that's 720. For each of them equal. Therefore, the alpha in the diagram is 720 divided by 6. Which is equal to 120 just the same. So if I put in alpha then this will be alpha, this will be alpha, this will be alpha, this will be alpha, and this will be alpha. Show that there are 6 of them. All angles equal, all sides equal. So this 8 centimeter dimension that I gave you is irrelevant because I don't need it. Relevant, don't need it. The next part is over here. Which is now telling us the vertices of that and the hexagon, and these lines are parallel. These lines are all parallel. Remember, once you have parallel lines, guys, not complicated. You have U angles, you have Z angles. Question says, what is angle LWX? That's the angle right here. LWX. Question is asking us for this angle right here. Remember, this angle is 120, you know. Don't it? Because all angles inside this thing are 120. So this angle inside is just 120 degrees. This one. What is now? Parallel lines that are joined give you U angles, co-interior angles. So this line and this line parallel. Those 2 lines parallel. And they are connected right here. So these 2 angles are co-interior angles. They add up to 180 degrees. And if this is 120, then this guy inside here has to be 180 degrees. minus 120 degrees. 120 degrees, Mr. Shaw, which is 60 degrees. The answer for that angle there is 60 degrees. Using co-interior angles, just see. Co-interior angles are up to one. Once they give you parallel lines, the brain must think co-interior angles, Z angles. Co-interior angles, Z angles, you have to look out for them. In this case, we're using co-interior angles. We call U angles. Up to 180 degrees. All right, so now on the next part now, right? That's all I want. So bonus on want part B, right? Part B is a construction. Yeah, part B. All right. Let me put up the two sides of the screen. And see what them say. All right, so they give this information. All right. So put the information up here that they gave you. Right? And put the question down here. What you're supposed to do. There you go. You don't want more than 5 minutes to do that. To do the construction, but draw one little something. Draw something like this on your paper for me, please. And construct what them say. Draw something looking like that. I will draw the actual paper. Just draw something looking like that and follow these instructions and do this. Do this. Do these. Do that. All right, give me 5 minutes. And then we'll break after this. Don't need 5 minutes for this. Is the construction now, you know. 4 minutes. You don't need more than 4 minutes. Just have doing a construction. Read the question, you have to just do a simple construction. 4 minutes to do a construction. Draw this little thing. Draw this first on your paper. Just draw something looking like that and do the construction. Based on that instruction. Let me make this a smaller. Work, 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 work. Time. All right. So the question gives us this diagram. It says a field of a sport club is in the shape of a quadrilateral RSTU. A scaled diagram of the field is shown below. Then it says, a lamppost is to be erected on the field at a point marked L, so that floodlights can be installed. The point L should be located in such a way that L lies on the perpendicular bisector of UR. So this is UR. The lamppost has to be on the perpendicular bisector, which is going to be somewhere down here. And also angle LST must be 30 degrees. So L to S to T must be 30 degrees. So it means that we need to construct a 30 degrees angle up here, so to find where T is. But understand that. There's a perpendicular bisector over here and a 30 degrees here to locate where T is. I have to construct it. So let's construct it over here. Sketch it and then construct it. Let's construct it over here. You have to do it on the actual paper and examine. That's what you'd have to do. So let's do that construction up here. So I'm going to clear this. Clear the screen. I'm just going to draw a shape similar to that one. Draw a shape similar to this, which is a line out here and a line looking kind of vertical up here almost, and a line down here, and then join up here. Close enough. So, come again. So up here says R, here says U, T, this is S. Let's construct the 30 degree angle first. So to construct the 30 degrees, we're going to construct a 60 degree arc and then bisect the arc. You don't need to construct the 60 degree angle. All right? So ready? This is the instrument we're going to be using. That's our compass. Let's change the construction lines to red. Move it down here. This is how we're constructing the 60 degree angle, right at this end right here. Put my compass a reasonable length. Lock it and then that one change it again. I'll make an arc that will be about 60 degrees up here. Come over to this end. Rotate over. And cross that one. That can need a little bit longer. Let's go back over here and make it a little longer. That's a 60 degree arc that I have. I don't need to draw the 60 degree arc. I just need to bisect this arc between this point and this point down here. I just need to bisect it. Let me change the color for the bisecting to green. Now come to this end of the arc, rotate over to where it's about 30 degrees somewhere inside here and bisecting the arc and make an arc. Come down to this end of the 60 degree arc, rotate over, cross that one. So my 60 degrees is gonna pass through that. So it's gonna fix it up a little bit. It's clear. I'm not going to draw it in yet. I'm going to draw the line from the S through that green intersection to get my 30 degrees. Let me bisect this side up here now. Let's use a different color to bisect. I can use the red. Let me use blue to bisect this angle up here. I'm gonna bisect, not the angle, this side. Put my compass a reasonable length more than half. If I put my compass more than the actual half of the line, right? To bisect, if I put my compass more than half. So half a mark is about here. You have to open my compass more than half to do this. All right? You're gonna make an arc below and above. Make an arc below. Oh, I didn't set it yet. I need to lock it. More than half. And lock it. So make an arc somewhere down here. And then make an arc at the top. There you go, there you go, there you go. Make an arc at the top above it as well. Somewhere up here. Then move over to the next end of the line. And then rotate around. And then cross that one. Come to the next end. Oh, I do that one already. And to get from this end as well. Oh, this one needs to be longer. I'll make it out here. This one needs to be longer. Where you gone, boss? Where you gone? Good, that is it. So I'm going to draw my lines now. Which color can I use? Let's draw my lines in pink, this pink color. Or this purple. So I'm going to use now, and just draw my 60 degree through the green. Remember, my 30 degree must go through the green from here. So from S out through the green. That line is 30 degrees from S. So T is on that line. Then I'm going to draw through this intersection, the blue intersection, that's going to bisect the line. Through the blue intersection, we'll bisect the line through the blue. Through the blue, Mr. Sharp, bring it on in, so through the blue. Where those two pink lines meet, that's where T is located. Put that back in black. That point is right here. That's where T is located. Right there. That is it. What about that? The bisect the angle, bisect the side, sorry, and then it. All right, hold on a second. Hold on a second. Oh, the same thing. All right. 30 minutes break. No, I say last yesterday. No. But there's a teacher over there. You can check Mr. Prince for the key.
Sure.
You want to do? All right.
Sure.
Yes.
Sir, if you're in the exam, and there's a question that you're stuck on, sir. How long does it, as in, sir, like if you're stuck on a question, um, is there like a certain amount of time you should give yourself to say, all right, if I don't know what it is, then we'll just move on to the next one?
What me not understand means when we practice that whole year, we say we
No,
give 10.
sir, like, sir, you know, like when you dip on a, when you do on paper, sir, or something, and your mind go blank on something.
You last key, so now go on next class, give over the teacher now on the back. Mason, remember
Yes,
our
sir.
practice, you know, we say we give 10 minutes for each question for the first 3 questions, 15 minutes for the next 4 questions after that. And I take it to section 2, and then give 20 minutes for each question in section 2, 10 minutes per part. And when you finish that, you're gonna have 10 minutes still left to look over. So there's no business talking on the question. After 10 minutes on a question, first 3 questions, you're supposed to move on wherever you are. You're not supposed to stop and be thinking and wasting time. CSEC don't set the exam paper and give any provision to be stopping and thinking for a lengthy period of time. If you're doing that, you're wasting your time. You're giving away the time. So if you're on question 1 for 10 minutes, right? And you're on a part that you're not getting through, you move left it. You're not going to waste your time on it. Because it then means that you're going to end up not finishing the exam 1. You're going to end up not doing some other questions that you are able to do. Because I'm sure that there are questions in section, like the last question, there are things on the last question that you're able to do. So why waste time on a question like maybe question 4, question 3, and you're trying to wasting time trying to get 2 marks when you're able to get 5, 6, 7, 8 marks on a question later down. So what you do, you give each question a set amount of time, and I've given you that plan, the amount of time to give each question as a general rule. So if you don't remember, this is it. 10 minutes for question 1, 10 minutes for question 2, 10 minutes for question 3, 15 minutes for question 4, 15 minutes for question 5, 15 minutes for question 6, 15 minutes for question 7, 20 minutes for question 8, 20 minutes for question 9, 20 minutes for question 10. You will have 10 minutes left. Some of those questions, you will not need that amount of time. Like, for example, question 7. You're not going to need 15 minutes for question 7. I'm sure you'll finish question 7 in less than 10 minutes, especially if you get one of the normal, the easy one there. So there are some questions you will not take that time that I give you, but that is a limited amount of time you want to give any of those questions. That will ensure that you do work and you get all the marks possible on all 10 questions. And then you still have another 10 minutes or more to go back through and look out anything you miss out. You don't have any business wasting time on a question, chasing down 2 marks, for example, when you can get 6, 7, 8 marks on another question in the same time. So time management is a critical part of the exam, and that's what we're trying to tell you guys from day 1. But the problem is that you don't really get to come on a Saturday. We will practice it to the T. Right? That is why you asked me that question. If you're coming on a Saturday, you'll realize that that is how we practice on a Saturday. So it's not a if, but a maybe. Work with that plan and you'll be fine. You know, the time, sit down and waste time and think about no question. Right? If a question a problem, move left it. You'll find another question that are not problems. Move left it, and then when you finish, you can come back to it if you have time left. But don't waste the time on a question, chasing down 2, 3 marks. When you have 12 marks to get another question. Next thing you waste your 12 minutes trying to get 2 marks, or waste 15 minutes trying to get 2 marks. But the same 15 minutes could have given you 12 marks or more on another question. You get what I say?
Yes, sir.
That is what you're doing, boss. So 10, 10, 10, 15, 15, 15, 15, 20, 20, 20. That is the plan. 10, 10, 10. First 3 questions that. 15, 15, 15 at the next 4 questions. 20 in section 2. Why is it 20 in section 2? Because each question in section 2 has 2 parts, most times, from 2 different topics. Like, for example, question 9, you get a circle theory, then a bearing, 2 different questions. Question 10, you get a vectors and a matrices transformation, 2 different questions. Question 8, you get a functions and maybe a measurement. Right? You get maybe a function, the f of x, g of x, and so on. They might get a quadratics. Or they might get a functions and a linear programming. I might get a functions and a speed time graph or a distance time graph. Something like that. For question 8. So you give each part 10 minutes. That's why I give it 20 minutes for the questions in section 2, because normally 2 questions each of those. And if you follow the time management plan, you will still have 10 minutes left to go back through, and anything you pass, anything you have to go past, you look back at it. You have to limit the time you give each question and the exam pass. So if you're on question 1 and 10 minutes pass and you're not done, you're supposed to move on from where you are, go on to question 2, move on. You can't give question 1 20 minutes. You're not going to finish the exam if you do that. So you have a limited time you give each question. Because you can't know that if you spend 20 minutes on question 1, you're going to find another question down the line to make up at the time. No, you can't. There's no guarantee. They're going to find another question down the line to make up the time. You have to give each question an allotted and limited amount of time, and you have to be disciplined about it. So remember the plan. And you have to do the exam and watch the clock. You can't just be working blind. You have to watch the clock and know when 10 minutes pass. That's why you practice. You must know what 10 minutes feels like. Why do we keep putting up 10 minutes, 10 minutes, 10 minutes? Because I want everybody to know what 10 minutes feels like. That's why I keep putting up 10 minutes for these questions. I must have a feel of what 10 minutes is like. When you're working a question and 10 minutes come, you must kind of know. You like a build an internal clock of what 10 minutes feels like. Get me, I say?
Yes, sir. That's some by one watching.
But don't it depends on the watch. You can't carry digital
No, it's a
watch.
regular digital watch, not the smartwatch.
You have to carry an analog watch. And if you don't carry an analog watch in the exam, don't watch with the hands ticking, tick, 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 tick. You can't carry a digital device in the exam.
No, like the alarm clock one, if you get what I'm talking about.
You cannot carry anything digital in the exam room. You can't carry an alarm watch in the exam room, boss. You can't go there if people have exam and make up nice, you clock the alarm. It's really easy. You can only carry a watch in there that is tick, 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 small, short and left and long hand watch. You can't carry nothing digital in the room. Nothing that is digital can go in the room. CSEC people them know, so people are smart watch, you know. They cannot talk to people and send messages and anything. Them know. So you cannot carry nothing electrical like that. Nothing, no electronics allowed in the room. So if you're gonna go in there with a watch, it has to be just a normal, basic, nothing digital can be on the watch. It has to be a normal plain, and I'm have to see the hands, them are tick, 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 tick. We call it an analog watch, I think they call it. With a short hand and a long hand on it, and the hands sticking around. They don't want to see anything digital. You cannot go in the exam with anything digital. Okay, my boss?
Yes, sir.
I can't go in an exam with nothing alarm. You crazy?
No, sir, I'm not gonna set my alarm, I just go look on the watch, sir.
You cannot carry a digital watch in there. So once you tell me about alarm, you can't carry it in there.
I'll
If you
say,
want
yes, sir.
If you want to go there with a watch, go to the store and buy one of them simple, basic, old-time analog watch. I can't do fancy either, no Rolex and no fancy looking watch. And all them things there. That'll be basic for them to give you a chance. That would be like the most basic watch ever. Anything we look too modern, they want to turn it backwards. And you can't get a digital watch where you put on the screen that is digitally ticking around. You know that what the digital one will look like an analog, you can't carry it either. Once they see that it is digital, you can't carry it in the room. Has to be analog. You have to see the gears working. Tick, 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 tick. That's what they want. The ones that work with the gears. Nothing digital. And they're gonna feel that you're able to communicate with other people and they can store stuff on it and all of that. They know that these watches exist. People are cars with a watch and browse the internet with a watch and all these things. They can't go in with not electrical or digital like nothing electrical. They want to watch it when they go wind it. Repeat word. They don't even want to watch or you watch. They don't want to watch. They go wind it up. One of the whole time watch them. We have to wind it up. Wind up a spring and I fight to work.
Sure, you can't serious about them kind of watch they really serious. After my analog watch can't do that.
All right. You don't know what kind of analog whatsoever. But what I can tell you, price them test you can't use. So I have to tell you. The man tell you, we have a clock in the room. And we have a big clock in the room. And you have to work with their clock. That's what they're gonna tell you. So don't be surprised if they tell that they can't use it. It's a very strict, you know, have to build all kind of them that the cheap. Then come on. Oh, I forgot to send it again. Send it again. Just do those reports. Huh? Good. I forgot to send it to the group. Yeah, fine. Mathematics, all the live hours, 24 minutes, and I said, live hours and 24 minutes. But clock, some guy, I might have a clock on the screen, ticking down, so you can know. Yeah, don't know. One another that alone, one do might do one activity too. No. I'm sure as well. You have to go one to your pass. No, we usually start it earlier. For exam, like maybe 3, 4 o'clock. Start it earlier. Our body can go early. I just send it to the group. Yes, Mr. Mace, I understand, boss. There's no electronic in the exam, yeah? Not big. Huh? Which one? Let's see the order construction. Unit construction. You can find it. You can find one. Just send it there. All right, up. Several top on the mind. Several top on the board. Okay, about them tomorrow. Rock with me. Sir. Oh, I mean, do you think I'm going? Yeah.
Yeah, re-north when I empty stomachs here.
So when you go get the food, what time now?
I have to go out of the food. Like this.
The other no.
All right. Here. Yeah, but
do that young girl in my class. Who's that girl? Just come here, whatever, so over there. And then he's on from the class. I want to get my money. Boss. Come on, count. All right. Just come on. By the more this, people just putting up this on the more. That now work, but what's going to work? But at the end of the day, I'm not people doing work now. You have to do the work. That's what it's all about. You guys have a practice, man. It's going to paper again. Bring a set of paper, sorry. Do a paper. Find out what I'm going to do yet and do it. The bearings. Let's do the bearings. Let's do the bearings. Today, yeah, the bearings go today. I'm going against schedule for today. Schedule for today is not good. Go on, bearing system. One class and then bearings. One class over the bearings, like bearings all day. I think we have two class over the day. all of that. So that's new about this class, then but I also go to remind. So go and watch all what the videos and practice. Saturday class always go practice. So required. What we did talk about theories. What we did talk about theories. Right? Because of theories alone. Show me about these three videos of viewing. So theories alone. Did this way. It is here to be still. I don't know if there's 2 minutes left. 30 minutes fast. Yep. I never believe it. What and call it. Huh? You don't believe it because we have worked fast in exam. Watch the time. So when we're supposed to start the next.
The harmonious eruptive will be happy, roughly will be happy. Some college Baltimore, Florida style, but it said your agents, they did not so much like me, agent was saying, even if I did not know what they said was like what about PPS, not really so much of PPS from there, and it was one voice.
The time up. I'm call them Bobby. Give them 5 more minutes and call them.
No, no, sure. He's not sure. He's like, yeah, when I like, you know, that's great. You want to take over?
Let's go, let's go. This one is starting with, but you have to decide what you're doing, you know. Start, you know, give me a question all day. You know, a question, Todd? Huh? Which question two we doing now? Come on. One minute, 20. Which paper no one? January 2025? January, let's stand two. 2025 January, see there?
Say two.
Say to you.
No, cellular devices. January 2020. This one? That's a January 2022. January 2025. Which question? Part what? Part A? Or part B? Come on, Maita, you ask the question. Which part of the question you want? Huh? Yes. The exam paper then? Which one you want? 2.1. Let me try. I'm have to dig it up. This factorization I want to. Hey, you know, so we use a time. We use a time for another week with some more papers. Those papers that cannot write the solution on the paper, that's what can't bother them this. Which one? 2010. No, sir. You can't tell me that. 2010 paper that I write on the paper and not the space not provided for it to write. And those days they used to give you a booklet to write in the exam. Huh? These are actual past papers they're looking at them. Yeah, these are a booklet. First time they used to just give you actual colony to write with. and give you a string. I was a hole in it. When you finish, they give you as much as you want. And when you finish, you put the string in it and tie it up with the name and stuff. That was before. And then I started reading a booklet. A lot of pages. So that is already bound together. You don't have to think it again. And then they move to this now where you write on the paper itself. And the cutting down the spaces that you have to write. Because they save in paper. But anyway, this is it, guys. What means we're going for this? This is it. This up here is actually x squared minus 49. Write it out. This is x squared minus 49. This is x squared plus 2x minus 35. And this now is x squared. Put it down there, so. X squared minus 49 over x squared plus 2x minus 35. To simplify. Leave it here, so. That is this question, the factorized those. I really wasted time with them questions still, honestly. Then over here now is to do this question. This is to make S the subject, this is A, B. Make K the subject, and make M the subject. S equals K minus M squared. Make M the subject. And then you have this under here. So. Easy question, these. All right, go on now. 10 minutes. No need 10 minutes, 8 minutes. All right, so you want a paper? I can't have a paper question.
So finish early, I go out to some quick time. Finish.
It was like, I said, I said, would come on, I'm going to 50% of it. Oh. So I'm not going to want to paper instead. So no, abandon question twos, abandon question ones. But some people want some of the consumer method questions. That's what that's question ones. Huh? People. Search and see for the find people. What else we want to do? I find people on the I tell you more. Yes, Yeah. No, manos comando people like tomorrow. I can't look at the app. What evening? Yeah, but I just bring some papers tomorrow. People can just select. I'll be here every day. Come on, work. Continue practicing for the week, and if you come for a problem, you can ask me. That's all. I don't have anything else to teach you guys enough. I think so, but I always advocate for the school here for them to give the fourth farmers a couple of days. Well, in fact, I was talking to Mr. Prince about it. Ask him to give you at least 2 days for the exam. So them should I really get Wednesday and Thursday at least. We're talking to Mr. Prince. Mr. Prince over there, so the head of math department now. Yes. So I'll mention it to you. The fourth farmers Wednesday and Thursday. Sorry for the math. 1.5 minutes to go. Come and find the next question I want to do, you know. What can do, you know? Can just do 1 and 2 in a spin, you know, because the question are too easy. God no. Well, all right, we're doing 1 and 2 now. We're doing 1 and 2 for the next 2 segments. 1 and 2. So anyway, whether 1 or 2 we can do now. Let's just do it that way. Because them questions are ridiculously easy, you know. So
Sure.
I know some of the consumer will be give you a challenge sometimes. Like the payroll questions and all these things. The money question, yeah. So we can find some of them if you want. Question 1 and 2 we're doing now. We're going to do question 1 and 2 now. Question 1 and 2 is maybe the next segment, depending on how many get through. And we will say we still have the number 7 to do the pattern question. We didn't do pattern question yesterday. All right. So I take 1 or 2 now. I take question 1 or 2. Huh? Yeah. That's why I left it for last. 2016 and 2019, question 2 or question 1? 2. All right. 2019, question 2. That's what you want next time, no problem. Work out this one quick and fast and then we'll move to that one. All right, over here first. Question wants us to factorize this thing. This is the difference of two squares, two perfect squares. The same as x squared minus 7 squared, which then becomes the difference of the numbers times the sum of the numbers. X minus 7, x plus 7, done. And this one is a quadratic, because a trinomial has 3 terms to factorize. This one is the factorizing. Why make it easy? Why is it easy to factorize? Because the first value here is just x squared. So the only factors in the bracket of x squared is x and x. Then it's factor of this that's coming here and here. And those factors have to be just that the difference is 2. One is different because the last value there is a minus. It tells me that the 2 signs in the bracket are different. Factors of 35 where the difference is 2 is 5 and 7. 5 and 7. Because this middle term is positive, the larger of the far and the near product must be positive. The far product is 7x, near product is 5x. 7x is large, I have to make it positive like the middle term. So it means that I'm putting the plus here and the minus here. Those are the 2 factors of that. Done. And this one now, basically combining, this is a 49. You're combining the factor of the top one up here and the factor of the bottom one under here. That's what this is. So this thing really becomes the difference of 2 squares on top, x minus 7 times x plus 7. That's what the top is. And then the denominator is this. X minus 5 times x plus 7. So x plus 7 cancel each other. And so if with x minus 7 over x minus 5 as the answer equals x minus 7 over x minus 5. That right there is our answer. We'll come over here now. This question says we have to make M the subject of this thing. Make M the subject. Right now it is negative on this side. I'm going to bring it over this side and make it positive. Take this S and bring it over this side and make it negative. So my first transposition is that the M squared becomes K minus S. Then to get rid of this square, I have to square root both sides. Square root this side and square root that side as well. This square root will cancel away that square. And so I'm left with M equals the square root of K minus S. The only thing I would say about this is that, in fact, this can be a plus or minus square root. Because when you calculate square root, you have to remember that the value can be plus or minus. So I'm going to leave the plus or minus on it this time. But I feel like if you just left this alone as the answer, for this question, CSEC will give you a mark. But if you put the plus or the minus, I will give you the mark still. Get me? Because I did not tell you anything about the M. If they said the M was only positive, they could just leave this alone. But they didn't classify the M for you. So I would suggest that you do this one and leave it that way. All right? Next part down here now. Says Lisa has $56 to buy a total of no more than 70 red. No more than 70 means 70 or less. No more than 70 red balloons and green balloons per party. So the sum of the red and green balloons can pass 70. That's an inequality there. They said she buys no more green balloons. She buys more. She buys more green balloon than red balloons. It means that the number of green balloons must be greater than the number of red balloons. But must buy at least 15 red balloons. That means that the number of red balloons must be 15 or more. At least 50 means 15 or more. That's another inequality. It says each red balloon costs 75 cents and each green balloon costs 50 cents. Let X represent the number of, let's X and Y represent the number of red and green balloons. So let's put it up here now. So the number of red balloons is X, number of green balloons is Y. The sum of the X and the Y can't pass 70. That's one inequality. The question wants us to write inequality, but it's a 2. But there are more than 2 inequality in this question. First inequality related to the total balloon that she's buying, no more than. So this is X plus Y has to be less than or equal to 70. It's first inequality. I think they made a mistake when I put 2 here. I think they really meant 4 or something like that. First inequality. This also presents an inequality now, but she can't spend more money than she has. Get me? She can only spend $56 or less. Then now it says she must buy more green than red. So remember, the number of green balloon is Y, must be greater than the number of red balloons, which is X. So another inequality is that the Y has to be greater than X, just greater than alone. But she must buy at least 15 red. So the number of red, which is X, has to be 15 or more. X has to be 15 or more, greater than or equal to 15. Then now we have the money information. The money she spends on the red balloon, put another one here, which is 0.75 times X, that's the money she spends on the red balloon, plus the money she spends on the green balloon, which is 50 cents times Y, 0.50 times Y. That total money has to be less than or equal to the amount that she has, less than or equal to 56. So I've given us 4 inequalities instead of 2. But don't ask for 2. So I guess any 2 you give them, they have to give it a mark. How much marks for question value? 2 marks. So they give you more, they give you a lot of information. They give you information that would allow you to write 4 inequalities, but they only ask for 2. So I don't know if it's a mistake they made or what, but that is it. Question done. All right, that question done. I want to say 2019, 2016 first, 2016 first. It's May 2016 I want. Let's do it. Son, do it. Let me bring up a new one, a fresh one. Let me bring up a fresh one. This time, where is it? 1 or 2? Inequality. Part A and part B. Yes, sir. All right, 2 parts. So bring it up again. There you go. 2016. 8 minutes. 4 minutes on the first part, 4 minutes on the second part. I don't need 8 minutes. This has to be easy. Because I want to put in some love, you know, I know how to put this down. Because I want to put in some love as well, the car marks. So, but I don't want to put that one on too. They were better than the first one on too. Or B, transfer arithmetic. Huh? This one? Here. 4x squared times 4x cubed over 2x. Got it? This one is this, rather a single fraction. This one down here is the factorize this thing. In 5 seconds. By the way, this topic so is going to give just 1 hour, right? So we can just give 2 hours to question 1 and 2. Combine. So save 2 hours. So leave here by 7 o'clock or before. Huh? Huh? What is it? 4x squared minus 4. All right, over here first. To solve this inequality, remember, solving these simple linear inequalities, the same steps as solving if this was an equal sign. Same steps. The only difference that we have to remember is that if you have to multiply or divide by a negative number, you have to reverse the inequality sign. That's the only difference with this one. So I'm going to do this one. We'll group the x on the left side. I'm going to do it again, but I'll group the x on the right side. I'm going to do it 2 ways. Just to show you, depending on which side they decide to group the x on, what the difference would be. So to group the x on this side, to make it the subject, I'm going to group the x on the left side. So I'm going to take this 5x and bring it over here. Take this 8 and take it over there. And change the sign. So I have this minus x over here, stays minus x. This 5x comes over and becomes a negative 5x. The sign stays less than or equal to. This 2 on that side is already there. This 8 goes over and becomes a negative 8. This sign becomes negative 5x. Negative x and negative 6x, sorry. Negative x and negative 5x become negative 6x. Less than or equal to this becomes negative 6. To move this 6x is negative 6, I need to divide by it. But because I'm dividing out a negative number, I have to reverse the sign. Let's write it out in the red so don't forget. I'm going to divide by a negative 6. But because that's a negative number I'm dividing with, I have to reverse the less than or equal to sign. And then now the answer becomes, when I divide by this negative 6, it becomes x. Sign is reversed to greater than or equal to. Divide this by negative 6, it becomes a positive 1. That is the answer. And do it the other way. We will group the x on the right side instead. So what the difference is. In this case, I would take this minus x and bring it over here. So this 5x is going to remain there. This minus x comes over and becomes a positive x. The sign stays less than or equal to. This 8 is on that side, which means a 8. This 2 comes over here and becomes a negative 2. So it's 8 minus 2. This 8 minus 2 right now is 6. Sign stays less than or equal to 5x and x is 6x. Now I need to divide by 6 to make x by itself. But because I'm dividing with a positive number, there's no change of the inequality sign. So then this 6 becomes 1. Sign stays less than. This 6x divided by 6 becomes x. So 1 is less than x. If you read it from the right, you see that x is greater than 1. So you can say, i.e., that is, the x is greater than or equal to 1. And that is the same answer. The next part now says, show your solution on the number line. They want x greater than or equal to 1. So 1 is a critical value. So you're going to put a circle on the 1. I'm going to shade that circle on the 1. Why am I shading it? Because the equal is a part of the inequality right there. Then the greater than 1 means that I'm going to the right of 1. That's x greater than or equal to 1 number line. Now, when would I leave this unshaded? If the equal right here was not there and I was putting this, then to show that 1 is not an included value, I would have just shown an unshaded circle for this inequality up here. Have to remember that. All right? But for this question, greater than is there. The equal to, is there. So the circle on the 1 has to be shaded to show that the 1 is also a value. That x here. That is a number line. All right. Down here says expand and simplify. Expand and simplify. So I'm going to multiply this by these two terms in the brackets, and I'm going to get 2x squared when I multiply this times this. Then the 2x times this 5 give me 10x. Then here now I multiply with a negative 3. Remember, I multiply with a negative 3, not just a 3. So negative 3 times x is negative 3x. See, careful part, you know. Negative 3 times negative 4 is positive 12. Minus times minus is plus. Consolidate these two values in here. We get 2x squared plus 7x plus 12. That's we have expanded and simplified. That finishes that question. But good. Let's continue down to the next part. Next part says we have to simplify this. Up here, actually part of it is multiplying indices. When you multiply indices, you add the power. And when you divide by another index, you subtract the power. You can multiply the 4 times 3 first, which is 12. When you multiply this x squared and this x cubed, we're going to get x to the 5th power. Okay, add the powers. Let's write it out. X to the 2 plus 3. Divided by this 2x. This is x to the 5th power. I get x to the 5th power. This is x to the 1. So now you have to subtract the power. When you divide it, subtract the power. So it becomes 6x to the 5 minus 1. Which then becomes 6x to the 4th power. I think maybe I did too many steps, but that's how it is. But I broke it out from here, you cancel down from here, saying no. Go could I do right, yes. So that's okay. 2 into this 2 goes 2 times right here. We could say x into 1 of this. Make it a square. Then the answer would have been is 3 times 2 is 6. And then x squared and x squared give you x to the 4th power. Same answer that I've done. You could have just gotten it quickly, like, but I just want to show you. All right, that is that. Next question. Make this into a single fraction. To make them into a single fraction, you want them to become related. So you want these two denominators to become the same. One way of making them same is that you can take this denominator, multiply it up the top and bottom, and then take this denominator, multiply it up top and bottom. So I'm going to multiply this fraction by 5 over 5. Multiply this fraction by 2 over 2. That will make the two denominators become 10. And when you have the same denominator, they are related. You can just add the numerator values normally. So this then becomes equal to 5 times x is 5x. 5 times 1 is plus 5. Over 5 times 2 is 10. Plus 5 times this 2 is 10. 5, number 5, yeah. 2 times 5. 2 times this minus x is minus 2x. Over 2 times 5 is 10 here again. Now they have the same denominator, so the answer is going to have that same common denominator. They were adding numerator values. So 5x and minus 2x gives you 3x. 3x that. Then 5 and 10 is 15. And that is it. That expression over 10. All right. Then it wants us to factorize this completely. So look here. That's the difference of two squares, you know. But when you have a common factor tied into the difference of two squares, factor out the common factor first. Always do that first. So common factor here is 4. You factor out the 4 first, you're going to have x squared minus 1 left in the bracket. You have to remember that 1 is a perfect square. You have to remember that 1 is a perfect square. So this one right here is a perfect square. It can be written as 4 times x squared minus 1 squared. Because 1 is the first square number as b equal to 1 squared. And this now the difference of 2 squares. And so it becomes 4 into x minus 1 times x plus 1. And basically that is it. Anything else? Just stand up.
She's a 90-degree anti-clockwise rotation on distance.
Yeah, rotate so yeah.
So 90 anti-clockwise.
Yeah, but you have a center point of rotation.
So you have to center jar to line and
We don't have to do that because most time the center rotation is the origin. Right? So if you look here so now. Look here so now the point of us rotate down to yes. About the center. And then as I always say, draw the L out to this. Draw L out to this. That's the idea as well. Whatever you rotate it up here, up so. The part here that was here, gone up yes. And the top of it gone out this. You understand that? I'm going to show you. Find the person. This is 2020. Which question are we doing next, guys? Huh? Or 2019. What am I going to show them guys or something? 2021 to share this. Let's find this. Huh? So this to this is clearly a rotation. Why? Because this base piece that was horizontal is now vertical. Clearly rotate on. So if it was horizontal and then vertical, that's a 90-degree rotation. You can see that this end rotates down up this way. So it's anti-clockwise right now. But I'm saying most time the center rotation is the origin. So you can just kind of check it. So I can say, okay, this point, if I rotate the line here to this point, 90 degrees, so it will come down this one, sure. Okay. And then now, but this point out here, I just see like, I call this like an L. Like you rotate in the coordinates from here. So if I take this like an L thing, I just take him to this point. I rotate it 90 degrees. This horizontal piece is gonna come up here. And this piece at the top of it is gonna come across here. So you see it takes it from here to there. So based on that, you can conclude that this is they've used two perpendicular bisectors of line joining corresponding points. Let me show you. So the way how to construct and find the center, which is going to be this, right? You have to join the corresponding point and do two perpendicular bisectors. So a good corresponding point to join are these two right now. Join them. Then I want a perpendicular bisector. 1, 2, 3, 4, 5, 6, 7, 8. So the bisector is going to pass through 4 right here. So, and the perpendicular to it. So since it's horizontal, you know, so the center is on this line. That's 1, right? We need to do another one. That's 1. Let's say we now use these 2 points. This and this correspond, right? These 2 easier to use enough. If I join them, perpendicular bisector really pass through the sun. So it must be like this.
So use two perpendicular.
Use 2 perpendicular bisector and find where they meet. If I to use this other one out here, this to this. Or on a perpendicular bisector of that line. Or that the perpendicular bisector of that line. And you find the midpoint first. So you can counter off to find the midpoint. So you can say, okay, from here to here, count it off. It is 1, 2, 3, 4 up, and 1, 2, 3, 4, 5, 6, 7, 8 across. So the midpoint is going to be 2 up, 4 across, right? 1, 2, 1, 2, 3, 4. So this is the midpoint. If I'm in the exam, I can put my protractor upon it. Like so, I want 90 degrees. Right at that point there. And draw it through to 90. This is the pass through the 2. Right? You can do that in the exam room. So after I find the midpoint, you put the protractor upon it. Put the protractor upon it. Position it right there, so I pass through the zone. Right, so and now the pass through here. So by the 90. Yeah, man.
Sir?
Well, I'll put up another question. Which question you want? Which question you want now? Oh, is it? No, which question you want? 2019? 2019, you want? Which 2019 you want, my boss? 2019 B? Question 2 you want? Question 2 you want? These things are too easy, you know. Improve. You don't want to get better. Show you something. Let me show you something. Let me show you something. You and everybody showing you all something. Great. Pay attention. Not slow, man. Come up. Where that go? Why am I plugging in box? What is that about the code? I meant to think. I took up a while ago. Huh? Make it go on, bro. All right. Which question you guys want? Coming up. Come up. Show these kids something quick. 2019. So question here. So it wants you to simplify these basic things. I write them down quick. That is 3p squared plus 4p. Yeah. Too easy, don't it? It's too easy. And then you want to do this one, and then invert and multiply. And then you want to do this one. Because that's too easy, you know. You wanted to solve that one. Boss, may I ask you for a question? You're gone. Sir. Sir, what? Emergency what? Then I want to do this expression and solve it. I'm waiting for this thing to come up and just come up. All right, then come up and show it. All right, guys. You know what? We say which question you want on 29? I can't even say one on 2019. Serious. Did you say one on question 2019? Sir. Huh? Yes, sir. But the part B. Oh, so I'm not showing you now. Watch this now. Showing you guys something. Yes, you don't want this no more. Show something. There you go. These are people in this class graduating university overseas. The CSEC math admins in this room, just like all of you. See there, got this picture today. No, very disciplined, quiet, to the right of the front. See that? Full scholarship. Don't pay a cent for university.
Sir, what's your major?
I think she should something in science. Some science thing. The next one here, Dubai, Abu Dhabi, full scholarship from this same program. See that? See that? These are students sending back pictures. Used to be in this program, going on to greater things. Want some more? Huh? Want some more? You have plenty more. All of them send me them pictures when I'm graduate and everything. Huh? Former student who graduate full scholarship to NYU in Abu Dhabi. See? NYU Abu Dhabi. Look there. See there? Don't be a cent for your education. Was in this program, like you. See that, and I've got more on the whole on. I want to see pictures of all of you graduating and things. Years from now. Yes. You must all come out to do your best self. All of you. No matter the foolishness. And send me pictures when they reach. See me. Oh. See when I'm seeing a battle, we don't see when I put in a battle, see me. Yeah, but then pass through, did well. You next. You closer to them. Yeah, you next, Miss Patriana. No joke. Serious, you know? So I'm talking like a joke, I'm very serious, yeah? Eh? Better say how. All right. Yeah, no. All right, guys. Which question one? Part B. Part B, my part. This you want though? This you want though? Somebody are wasting the water. This you want though, part B? Huh? Come on, my final question you want me to do, man. Come now, which paper you want next? I can't know. Which paper you want next? Huh? Yes, I said we can do question 1 and 2 in this segment. So tell me which question you want. Don't put it up on the screen. June 2023. Huh? Yeah, tomorrow. June 2023, you say? Yeah. God. There's something. June 2023. I cannot find it. I'm search for it. One and two. We're doing 1 and 2. I bet you this one is a done one on the screen. Find another week. Let's find another week. Which part of question 1 you want, right? Second part of question 1. BRC, B. Sit here on the screen, giving you 4 minutes for this one. I only need 4 minutes for this. Four minutes for this question.
That's a reasonable.
That's a 74, yeah. Put down a straight line. 74. Put down a straight line, 74, 74. 140, 148. 140 and 34. That's correct. And put down this term at 180. Yeah, that's correct. Site quadrilateral. Can't see it. You have to see it. When we look at CSEC, then I see the 4 point on the circle. Your brain supposed to have cycle quadrilateral at the same time. The post parent.
1 minus.
Come on, work. Work. You finished? Another minute? Come on, 2 minutes. Already know. All right, this question says, I'm gonna need a calculator for this question. All right. Question says, Eris works at a call center for 35 hours each week. He is paid an hourly rate of $11.20. Calculate the amount of money he earns in 4 weeks. So it's 4 times the weekly amount. The weekly amount is obtained by multiplying these two, $11.20 per hour, and he works 35 hours. And then to get 4 weeks, you have to multiply by 4. So the answer for this one is 4 weeks times the weekly amount, which is 35 hours at this rate. 35 hours times the $11.20. That's what we're multiplying. This is the weekly amount. This is 4 times, but might need the weekly amount, and we work it out, let me put it inside here. Or might need it later. So let's calculate it now and put it inside here. So it's 35 times $11.20. That's $392. $392 a week, and then we multiply that by 4 now, you get the amount that he earns in 1568 in 4 weeks. Next part now says, in a certain week, you work 8 hours overtime. Overtime hours is paid at 1.5 the usual rate of $11 something. So it means that the overtime rate is equal to 1.5 or 1.5. 1.5 is same as 1.5 times the regular rate of $11.20. So it means that the overtime rate is this calculation. So work it out from now. 1.5 times $11.20. That's $16.80. So he earns $16.80 for every overtime hour that he does. $16.80 per hour overtime. It says, find the total amount. Oh, you work 8 hours overtime, but you don't want the total amount of money he earned that week. So the total that he earns that week is equal to the regular plus REG. The regular rate or the basic rate plus the overtime. The regular rate plus the regular pay plus the overtime pay. Let's try to do that way. The regular pay plus the overtime pay. This is the equal to. The regular pay is the pay for the week. This is $392. Plus the overtime pay is 8 hours overtime times this amount of money per hour overtime. So it becomes 8 times 1680. Whatever that works out now to is the answer. So it's 392 plus 8 times 16.8. 526. 526 I'm getting.
Yes, sir, 0.4.
526.4. I put 40 because it's money. $526.40. Can't put 0.4 on the paper. You put 40 because it's money, dollars and cents. That's it. Which other one you all want to do? Which other one? Come on. You all need to find the questions that you all want to do. You don't have a problem with the consumer arithmetic questions. Find them. And I have a problem with them as you. Come on. Which one next? Anybody online have any that they want to do? Question 1 or 2. Any question from question 1 or 2 we're doing now? First, you said I just want to combine the 1 and 2 segment because not a lot of persons interested in this question. Nobody do have any that they want to do? I bet it's me find one go, no, can't be. I can't talk about it.
Yeah, better.
Don't find question go, no, man. I rest. Been finding question giving it in September. Remember all these papers in the group, you know. So you can look on them if you want. January 2020. Question 1 or 2? 1B? One B. 2 pages. I bring it up over here as well. I bring it up over here as well. January 2020, right? Be alone, I want to see it too. Be alone. Sure, you want to see. Just ask if you know want to see it.
Key also, sir.
I should have just the things for the key.
Yeah. There you go. Let me set the time for this one. Give me 8 minutes. Come on, work it, work it, work it. Must have something else now. It's one more. Come on, work now, work now, work now. Yes, I'm gonna like what somebody else. I don't know that room. So I don't want We were, I don't know already. Huh? They'll give it up on your device. There you go. You know, just but so just like that. Reverse out the 7.5 yet. No, in the reverse of the 6.5. Yeah, because my friend last night I missed the total figure of 8 something. I said, wait, what is? I'm looking to know, I said, reverse of the 7. Or something. Please. So that's the work number for weekend. For weekends. So I'm kind of first. So I'm kind of no, but remember says CUG, remember says CUG, and it's free as compared to paying the value in the first time. That's why I look at it. Yeah, no. Hey, okay. So I said, yeah, you have to must have about it, Because they do not understand. Yeah, man, they do not understand. They do not understand, man. They do not understand. So that's all you think. I've met them to the work. Then to question them about it. Yeah, the one I question them already. I'm about to get back. They get half an hour every 2 hours. They get half an hour break. That is the matter one of the yes. Good morning. My tell them early, my finish early today. No, because them question we have left, they not just in them. No, then I can't easy to show my like someone answer them. Gone to the main question of the mass. No, we got it. Very strong. If you cannot, you can't tell you, I will do enough fever there and fever myself. That's why them come and take our whole team of the man one whole of it. I want to work with them again. Definitely going on people with personality. What does block people? Let me know. Just going on people, what does block people? Personality. Too sweaty. Yeah, we know, but I don't see like y'all don't want to do the news. Continue. All right. Okay, no problem. No problem. No problem. All right. Let's do this quickly. Find the next question that you want to do, please. Ready? This question says, a stadium currently has seating for 15,400 persons. All right, and a seating capacity of 15,400 seats. Says calculate the number of people in the stadium when 75% of the seats occupied. So it's basically 75% times 15,400. That's all. What I work out to?
11,550 people.
11,550. Next part says, the stadium is to be renovated, new seating, capacity of 20,900. In other words, they're increasing. What are they coming from again? Coming from 15,400, right? 15,400 and increasing to this amount. After the renovation, what will be the percentage increase in the seating? So it's going to be the increase divided by the original amount times 100. It's going to be the increase over the original amount times 100%. So the increase is the difference between this number and this number. So that's going to be 20,790 minus 15,400. That's the difference. Divided by the original of 15,400 multiplied by 100 to get the percentage. That's what you're working on. What are we working out to?
35%.
35%. It's not too easy for you. Next part says a neon light flashes 5 times. Number 5. Every 10 seconds. That's like a ratio. 5 times to 10 seconds. Show that it flashes this number of times in one day. You can do this 2 ways. You know, we can find how many seconds in a day. Divide it by 10. And then multiply that result by 5 to get the number of flashes. But then we can start out with this other ratio and the 5 flashes to 10 seconds, like a ratio. And then all we have to do with this ratio is build it up to 1 day. Make this side reach up to 1 day. So all we have to do. When this side reach 1 day in the ratio, then the value over here is the number of flashes. So all we have to do. I'm going to do it that way. So first, I want to bring that up to 60 seconds. That's 60 seconds is 1 minute. So I multiply the ratio by 6 first to bring it up to 1 minute. Multiply this by 6, I get 30. Write this 6 properly. Multiply this by 6, get 30 flashes. So 60 seconds. And that 60 seconds is 1 minute. Then 60 minutes make an hour. So I'm going to multiply this down by 60. Multiply by 60 now. To see how many is in 1 hour. So multiply this by 60. We get 1,800 flashes. 1,800 flashes. In multiply this by 60, now we get the 60 minutes. And this 60 minutes, sorry, this 60 minutes is actually 1 hour. But I know that 24 hours make a day. So I need an hour, 24 hours, I need 1 hour now to become 24 hours, which is a day. So I'm going to multiply by 24 now. So the answer should be right, you know, I multiply this by 24. 1,800 by 24 first should give us the final answer that I want. That is 1,800 times 24. That is it, 43,200. That's what I said here, 43,200. So it's 43,200 200 flashes in 24 hours. That 24 hours is 1 day. But this was short. At 24 flashes in a day. All right, that's it. Which other question you all want? Number 1 or 2? We're gonna take another break at 4 o'clock. So we can do one more question. So 20 minutes before this time. Which other question you want? I think we'll break from that. We're gonna come back and just do some question 7. We're gonna choose them. Then after that, so you don't know at least 2 hours early. Unless you want to do a paper. I don't know if you want to do a paper. If you want to do a paper, that's fine. No, you can leave if you don't want to do it. Other people are interested. Because some people are trying it once. Come now, which question are the next? 2022, question 7. Which is after the break, we're going to 7. We're still doing 1 or 2 now. 1 or 2 now. Question 1 or 2 now. Find one. Come on. January 2019. That's too early. Question 1.
Sir.
Yes.
I want to do question 6, 2024.
You have to do question 6, 2024.
Yes, sir.
We'll pass that one. I'll do it for you in the break. We're really focusing on number 1 and thing now. We'll pass that one in the break. We'll pass that one. I'll do it for you in the break.
Okay.
It's on number 1 and 2 now. Already passed the number 6 questions. What's that? 2019. We did the number 6 questions yesterday. 2019. Where was it? I'm saying January 2019. I'm saying. Teacher. And he wants question 1, right? Said he wants question 1. It must 1 be more, right? I don't know, same one. Come here, Orlando. More the question than God. Man. Call Orlando for me. I can't understand more. I want to put the binary question in one.
Sir, the boy who is in, what's he in a red jacket?
Is it some type of jacket? Sir, the guy who had the problem.
And no,
Yeah.
The guy who had the problem.
No.
Sir, what do you mean?
Yeah, almost a bit far.
sir, no.
Sir, number 8. This guy is
Anyway, we'll go on no ways.
about 20 subject.
And if it's this them one. See there on the screen. Part B and C. Huh? Yes, it must be the thing them want. The binary. We went through binary the other day, you know. Which one you want? The binary or which part of it? Is the binary you want though?
That's a good one.
Yeah, my car. Go on, I'm going to 5 minutes to do it. Part B and C. Part B and C of this question. B and C, come on. Gentlemen, B serious, write out the place value of the base. I told you that the other day. Write out the place values. That's all you have to do. I will use the place value to get the number. Binary is base 2, so you go 2 to the 0, 2 to the 1, 2 squared, 2. If it's base 5, you go 5 to the 0, 5 to the 1, 5 squared. Right, or the place values. I remember say if you're using base 5, your digits are from 1 to 5. What's the binary number for 28? Four minutes to discuss then. Come on, 4 minutes. Question gone. Oh, it's over here too. No, on this part was. This is some. That is it. All right, breaking after this. Okay, sir. Huh? Agreed. get 100%, they must step on the top. Yes. People get 100% in the exam. People get all right. Then they have to name all of them. All of them come first. That after the year when the exam was multiple choice only, was about 20 people come first, you know. Of course, when COVID, when the paper did leak, 2 years when paper leak, and I used multiple choice alone to grade the paper. Yeah, it's about 20 people type first. I think I am at 100%. Casey boy was in it too. Casey boy was in the list too. I was in fourth farm. Of course, he was a fourth farmer. Fourth farmer. Top the Caribbean. Was tied for first in the Caribbean. Anyway, ready? Ready. You want to write this in binary? Binary means base 2. So you want to put out the place values. 2 to the 0, 2 to the 1, 2 squared. Well, this number is just 6. So 2 cubed will be too many. Too much. 2 cubed is 8. 2 cubed. So the place values in binary will be 1, 2, 4, 8, and so on. So what it is you want to know, to make up this 6, you want to know how many times you are using these values. And in binary, you can only use them 0 times or 1 time. Because the only digits you can have in base 2 is 0 and 1. If you're working in base 3, the only digits you can have is 0, 1, and 2. If you're working in base 4, the only digits you can have is 0, 1, 2, and 3. So those are the only digits you can have. So, how can we make up this 6 using these numbers? That's what it is. Remember, I can use a number once or none at all in binary. So the 6 that we have, we can use a 4 out of it. We can use a 4 one time, don't it? When we take out the 4, we're going to have 2 left. We can use this 2 as the 2. Remember, you have to complete all the places. You know? You're not going to use any 1. They put a 0, they're not going to use any 1. So this to base 2 is 6 to base 10. That is it. Simple. Suppose this was base 5. So them say find 6 in base 5. Suppose it was base 5. Them say base 5. Base 5. First, you have to do is put on the place values again. 5 to the 0, and write 2. 5 to the 0, 5 to the 1, 5 squared. So 5 squared, 25, we only got the first. The actual values are 1, 5, and 25. And it's 6 we're trying to do. So this question, how many times can we take these numbers out of 6? Can you remember, it can take them out up to 4 times. What is 6? So you're going to take a 5 out of the 6, don't it? You're going to use the 5 out of the 6 left. So you have to use this one as well. So that is 1, 1 in base 5. All right, let's do another example. Suppose we had the number 68 in base 5. Convert 68 in base 10. And carry it down to base 5. Some number in base 5. What is that number? So working in base 5. So the place values will be 5 to the 0, 5 to the 1, 5 squared, 5 cubed. So those actual values will be 1, 5, 25, 125. So you want to say how many times you can take these numbers out of 68. And remember, you can only take out a value in base 5 4 times. 0 times, 1 times, 2 times, 3 times, or 4 times. So you can't take 125 out of it. We can take 25 out of it, right? Let's put the numbers here now. So we can take out 225 them, don't it? So we can take out 225 them. Let's start with the number. So I have 68. We took out 225, so 50 gone out of it, don't it? So we have 18 left to take out. Out of this 5, we can take out 3 of it. 3. 3, 5 is 15. So out of 18. And we can use a number. You can use, if you're working in base 5, you can use the number as 4 times. So you can take 3 of 5s out of it. Then put 3 here, so 3, 5 is 15. So 15 gone out of the number. So you have 3 left. But all the place value you have is that 1. You can use that 1 up to 4 times. And it's 3.5. We're going to put 3 right here. So this number is equal to 68 in base 10. That is it. And if they give you a base 5 number, let's do it down here. Let's say they give you a base 5 number. So what is the convert? What is the convert? 3, 1, 6 in base 5 to base 10, to a number in base 10. So what am I give you that? To convert to base 10. 3, 1, 6. Then can give it this to convert in base to base 10. This can in our base 5 number. Base 5 number can only have the digits 1, 2, 0, 1, 2, 3, and 4. So this can be a base 5 number with a 69. Base 5 number don't have no 69. 2 in it will have 0 and 1. Base 3 number don't have no 3 9. It only have 0, 1, and 2. Base 4 numbers don't have no 4 in it. It only have 0, 1, 2, and 3. Get the picture? So base 5 number can't have no 5 in it and it can't have no 6 in it. So all this can be in a base 5 number 0, 1, 2, 3, and 4. In a base 5 number. Just like on base 10, the only digits I have in base 10 is 0 to 9. You know? In base 10, what we use now, the decimal system, the only digits that are in our number system is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 is 2, so we have to put together for 1, 10, and 1 and a 0 to make 10. You see that? If you use 2 out of those 9 digits, out of those 10 digits, 10 digits you actually have in base 10. In base 2, you have 2 digits. In base 3, you have 3 digits. In base 4, you have 4 digits. Base 5, you have 5 digits. So if it's base 5, you're in, you have 5 digits. 0, 1, 2, 3, and 4. See that? So this could not be a base 5 number. So we're just testing it with that. So change this. But let's suppose you have this now. I put a value there. Let's say this is a 4. I want to convert it to base 10. Convert it to a number in base 10. What is that number? What this means, you know, is that in base 5, you know, you're using up the place value for this one 3 times, the place value in this position 1 time, the place value in that position 4 times. So I will do this again. Still write all the place values. To this question, put in place values. 5 to the 0, 5 to the 1, 5 squared, 5 cubed. I don't need to come up here because it's just 3 digits to have. 3 digits. These values are 5, sorry, these values are 1, 5, 25. This I'm going to put down here so now. It means that I am using 3 of the 25s. 1 of this 5. 4 of this 1. 4. They write what this equal to, plus what this equal to, plus what this equal to. See here now, this is really 75, because 3 of the 25 being used. This is really 5, 1 of the 5, and this is really 4. 4 times 1 is 4. And they add them up. And that will be equal to 84. So it means that 314 in base 5 is now equal to 84 in base 10. But understand that. So the important thing about doing bases, in question base, write out the base values. You can go from a number to the base using the base values. Or you can go from base to a regular decimal, still using the base values. Write out the base values. Trust me. Alright? That's a quick way to do it. Some people teach this by rote method, you know, like one method, start and subtract and the remainder. Yeah, but I don't like that way. Because people do it that don't really understand what they're doing. Right? I don't like that way of stuff. Some people teach it that way. That's a method, that's a gimmicks kind of method that works. Down here, so now it says, John bought a car for $65,000 and the value of a car depreciated 8% each year. So if it depreciated 8% each year, remaining value each year is 92%. 92% remains, and if it depreciated by 8%, means they take off 8%, you have 92% left on the value. They take off 8%. It says, how much will the car be worth at the end of 2 years? You're going to depreciate it twice. So after you take off 8% the first year, 92% left. Then the second year, you're going to take 92% of that value, of that new value. So year 1 value, remember, you're going to have 92% left. Year 1 ending value is going to be 92% times the original value of 65,000. And I don't even have to work out this to see exactly what it is. I know that this calculation is the value at the end of year 1. And for year 2 now, I'm going to take 92% of that value now for the year 2 value. I have to see what it actually is and waste time. So my year 2 end value, year 2. Is now 92% of this value. (92% of this value which is here. And so I can just do one calculation now. So 92% times 92% times 65,000. That gives you the answer. Simple as that. 90% is 0.9, 0.92 if you want to do it that way. But I can type it on the calculator with 90% times 90, I put 90. 92% times 92% times 65,000. I'm getting 55016. But it's the easy which we use the subtraction of percentage. So instead of calculating 8% and then subtract, waste of time. You take 8% off of the value of something, new value is 92%. If you're adding 8% to something, then the new value would have been 108%. You don't have to calculate 8% first. Waste of time. If you add the value, if you add percentage to a number, the new value is 100 and something percent. You take off the percentage, and if you take off 10%, new value is 90%. You take off 5%, the new value is 95%. You subtract from 100 to see what the new value is. You're taking off percentage. If you're adding percentage, you're adding to the 100. If you add 15% to something, new value is 115%. If you take off 15% of something, the new value is 85%. Now 100 minus 15 is 85. You don't have to calculate the 15% first and then subtract. That is waste of time. So you subtract the percentage instead and apply the lower percentage. All right, where I'm doing now. We'll come back. Why not do some number 7? Choose the number 7 there for me, please. Now 4, baking for half an hour. And don't come and tell me half an hour quick. Yes, it's quick. When you're not hiding.
Sir.
So somebody in the group wanted me to do a question for them. Which question was it again? Somebody in the group wanted a number 6. Which number 6 you wanted? Somebody on the chat. Somebody on the chat. Sorry. First God.
Sir.
Yes.
I have to go to my French class now. So I'll just watch the rest of the recording.
Yeah, man, cool. Come on, somebody on the Zoom was asking me to read number 6 on a paper. Who is it? All right, first God. All right, half an hour break. It's on the screen, 30 minutes.
Oh, I'm finding CPG.
Yeah.
CPG.
The question asks for CPG. Yes. Inside here, sir. CE.
Not the whole angle.
That angle is a 90. And it's a 74.
Oh, yeah.
Boss man, look here. Let me tell you something. Once you see a tangent, your brain must have think tangent and radius, tangent and chord. Once you see a cyclic quadrilateral and diagram, your brain must have think opposite angles are supplementary. There are certain things that your brain must cut to.
So you can also divide this by 2. 32.
No, you cannot assume by how anything looks.
Yeah, that's what I'm saying.
You cannot assume by, you cannot go by a look. Don't get into the practice of going by how it looks. You solid theory to do it. It works, because over here saw 74, over here saw 74 because of the Z. It's a 74, no, it's a 106 here. This is the Z. So it's a 74. Over here, 74 too. And because that's a 90 to both line, the inner side the same, but that's all diagrams going to be like. So prefer use sound theory that down between a tangent and a radius is 90. Huh? Come on, you cannot see tangent, my boss.
My problem looks fine, like looking at the something.
We have to, nobody have to look at what is there. So once it's, look here. Once you see a diameter, you must be thinking. I'm subtended by a diameter at 90. The brain automatically must go there. Once you see a tangent, your brain must have think tangent and chord. And between a tangent and chord, no, and between a tangent and a chord, equal angle subtended by the chord. And between a tangent and a radius is 90. Once you see a tangent, those two must come at you. Looking for the chord that is with it. I'm looking for a radius that is with the tangent.
Yes, sir.
Do a paper. You do a paper. Oh, you know, I want to do it. Oh, I thought it was to your people. Yeah, you tomorrow? Yeah, tomorrow. I don't want to. So little English then. Yeah, good friend. I say, what is English? Oh, it's oh, but I have the English. English is first, not for Bible. You didn't like that? You didn't already? You read it, she didn't know it. Oh. Oh. Huh? When you have this man, this is another attachment to the man. Every man attached to that. This is another attachment that this is that attachment to the if you have that in your mind, and probably want to add to that. That's the bad mind. I think I do want to ask you. You most of the attachment when you're going to battle, go with a tool, you have a fight wide, you have a fight back. You go with a big heavy bomb right. You have a lose, you have to go and move when I war with them. When you go to war, my heavy equipment, heavy artillery, top of the tree, top of the line artillery. You have to fight gun. Put a home right now, PM16, triple magazine, extra long.
14 people in.
One minute. What about that? Para question one, no? 1 minute left. Yeah. This guy don't understand. They understand. What's your question left? What's your question? 122. 1 minute. One outside. Hmm? Yeah, what's that? One, done. All right, one number 7. So we're recording this. It was a pattern question, I believe, no? All right. Time's up, 28 seconds now. Which question I said? 2022? I think it's gonna be a short session. Nobody is interested in this topic. Jupiter, January 1? All right, cool. Number 7. This one? You're going to do it first, and yeah, yes, sir. You know it is. You have to do it first. Try it and never see what happens. 2022. Question 7. We have a second page. Is it this January 2022, number 7. This is the second page right here. It's smaller. So this one is about, they give you the pattern and you must put in the fourth, draw the fourth one. I'll complete this one. So to start this one for you. To start this one for you, you have to observe the pattern, see how you go from this to this, and from that to that, and then decide how you go from this to this. And I've started this one for you. You just have to complete it. Then now we'll complete the table as usual. And there's a small question at the bottom there. Come, 10 minutes. You don't need 10 minutes for this question, but give it 10 minutes still. Ten minutes. Complete the pattern. What the pattern would be. I just imagine how you would draw the pattern. Sit it up, what you draw it on, but that is it. And then you're going to complete the table. As I always say in the class, try to fill out the formula line first, down here. Because the formula line now will help you to populate the rest of it. Help you to populate these. We have the formula line first. Well, your time. 10 minutes. Stop. Oh. What video? Because I see the video. Maybe you want to keep working to one we can figure it out about the videos. So we have all the solutions then solve it. Now you can stand up, boss. All right, time. So over here, you have to observe how we go from pattern to pattern. So you can look at the first figure. How did I go from this to this? What was added? I want to draw on what was added. So this is what was added. This line, this line, this line, this line, that line, that line, that line. This line down here, that line down here. And then these dots were also added. This is what was added. That's what was added. Oh, this line was also added, this one. And this one. So that is what we add from shape to shape. So I can actually take this and just copy it down here and put it as my additional shape on this right here. And there you have it. That's the additional shape. That's the next figure. All right, you have to basically figure it out in the exam and draw this thing on your own. All right, but that is it. That's what the new shape would be. All right, they'll come over to here now to do our calculations. It's very easy, especially when we fill out this formula line first. So how can we decide? Because the same information up here now. They said basically the figures represented in the table, then a pattern, the numbers in a pattern must fill out these lines, these 3 lines. So look at it now. I want to fill out this line first. I need to fill out the formula for here and for here. Now what does that mean here is that you're adding 8 plus 8. You keep adding 8 from pattern to pattern. You keep adding 8 dots from pattern to pattern. So the formula starts with an 8n in it. I keep adding 8. But the first figure actually has 8 already. So you don't need to add or subtract anything. The formula is just 8n. But this one over here, we'll keep adding. We keep adding 6. That's a plus 6. And from this is a plus 6. So you keep adding 6 to the perimeter. So the formula has 6n in it. Right? Because you're adding 6 every time. Formula has 6 times this number in it. But the first figure has a total of 8. 6 times 1 is 6. You have to add 2 to make that 8. Plus 2. So then this is the formula for this column. As simple as that. That's where you get the formula. And then the formula will help you to fill out the table. Now this one is the next figure. 4 to this one. So we can just continue the pattern. Add another 8 to this. 24 and 8 is how much? Huh? 32. And add another 6 to this. Add another 6 to this. You get 26. Now, if you wanted, you could have taken this 4, put on the formula. You get 6 4 is 24 plus 2 is 26. Could have done that as well. Or you could have taken this 4, put on this formula, and get 8 4 is 32 right here. All right. Then now for this line, to get the figure n for over here, what we're going to do is equate this to the formula and see what the n is in this line. That's all you have to do. All right? That's all you have to do. Use the formula to help you. You don't have to figure out stuff when you have the formula. It's easy. So for this line, I'm going to figure out what the n is over here. By putting this equals 86 in this line. So put in 6n plus 2 equals that 86. Subtract the 2, get 6n equals 84. So we divide by the 6. 84 divided by 6 is how much?
14.
Huh?
14.
4 divided by 6 is 14. So n equals 14. So this line is 14. So that line is 14. You take the 14, I will drop it on this. 8n. 8 times 14 is how much? How much?
112.
112. And question done. This part down here says, for any figure n greater than 1, the number of dots d is greater than the perimeter p. Determine the value of n for a figure in which the difference between n and p is 36. So you want to get a formula for the difference, right? Now this figure is always greater than this. That's what they're basically saying. And the difference is the d minus the p. And you want that difference to be 36. That's what you want. You want the difference to be 36. The expression for this, you want to know what the n is when the difference is 36. The expression for the d is this, 8n. You put 8n right here. Minus the expression for the p is this, 6n plus 2. When you're subtracting all of it, you put in a bracket. That is equal to 36. That's when the difference is 36. And you solve that and you get the n from that now. So you subtract 86 minus 8n minus 6n is 2n. This is minus 2 equals 36. If you were to add it, you get 2n equals 38. Divided by 2, we get n equals 90. That is the answer. I'll tell you that the difference. You want to know what the difference is 36. They put the difference of the formula. Two formula, then they subtract them and put that equals 36. And it tells you what it is. So the difference is 36. Which one you want to do next? January 2023. This color inside is shaded there. Let me highlight it for you. Highlight it. Yeah, highlight it. Highlight it in black. Right. So inside here. It's shaded. That's it. All right, that area shaded. And bring up the so I wanted to draw the next shape on this grid. Draw the next shape on that grid. Let me bring up the paper over here. That's it. After that, the basically I want this table to be completed. That becomes a question, really. Complete that table and then answer this question down. We get left. All right, 10 minutes. Ten minutes to that. And play ball All right. Time. Same thing. I'll draw the next shape. So look at observe the shape on this one, the pattern on this one. And we observe that horizontally, this increase from 3 to 4, 5 across. Next one must be 6. Let's do that. 6 across. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I think I've gone too much. 1, 2, 3, 4, 5, 6. Right here. Then now, there are like a diagonal thing taking place down here. So starting under the penultimate block. So it's 1 under here, 1 under here, and it's 4 down, so we need 5 down now. 1, 2, 3, 4, 5. Yes, guys, that is a shape. Want to go to that? That's a shape.
Yes, sir.
All right, good. They want to populate this thing now. Hey, this question you can do it in less than 2 minutes in the exam, or 3 minutes enough. Pick and fast enough. Especially when you fill out this formula line first. All right? These numbers going up by 2. So since they're going up by 2 consistently, 2n starts a formula, 2n. And the first figure has 5 in it. In the first figure, 2 times 1 is 2. You have to add 3 to complete the first figure. So that's the formula for that column. Then over here, this one consistently going up by 4. So because it's consistently going up by 4, formula starts with 4n. But the first figure has 12 in it. 4 times 1 is 4. You have to add 8 more to make the 12. So it's 4n plus 8 is the formula for that column. Then this one now, you can realize that is a perfect square. But this is always a figure number. And it's always plus 2 and then the square. So the figure number plus 2, then the square. So it becomes n plus 2 squared. So it becomes n plus 2 squared. And then it will be worked out. You work out what it is. So it becomes actually squared number, n plus 2 squared. That's what we get. All right. And based on that, now we can populate, like for example, this line, which is not the next line, remember, not after 4. That's why I have these little dots here. So this is not representing the fourth figure. So be careful with that. This is not representing the fourth figure, this one. That's not the next line. So to get this one, we're going to take the 11 and drop it on the formula there. So 2 times 11 is 22, 22 plus 3 is 25. So right here says 25. You work out that one first already. We could take the 11 and try. Put the 11 on that. 4 times 11 is 44. 44 plus 8 is that 52. So good. Then for here now, the number is 11. We're putting it in this formula here. So it's 13 plus 2, and it's going to be equal to, it's 11 plus 2, which is 13, squared is 69. So it becomes 11 plus 2, 11 plus 2 squared. That's what the formula gives us, a pattern. And that becomes 13, which is 169. So put the equal 169 here. 169. And on this line, this is the figure number. That digit there, the figure number. So know that this is 23. And that's the figure number. And then to get this now, we'll take the 23 and drop it on this formula here. We get 2 times 23 is 46 plus 3 give me 49. Oh, it's 49 is there, I didn't realize. I'm going to take this now and drop it on this formula right here. 4 times 23 is how much? Plus 8. What that work out to? 4 times 23 plus 8. You guys can just look at this and I get it right. That's 100. Down here says, how many white figures are in figure 11? How many white squares are in figure 11? Let's look at it. Figure 11 is this line. So the total number of squares is 169. And the total number of white is 25. So color, I mean, is 25. So to get the number of white, you're gonna subtract them. The total is 169. That's if white plus the color. And here you see that the colors is 25. So I'm gonna subtract them. So it means that the number of white in figure 11 is 169 minus the 25, which becomes how much? 144. That's it. Which question are you doing next? Which number 7 next? Which number 7 next? Yeah.
This one right here, I had a different formula, but I got the same thing.
That's it. You know, the same formula then. If you expand it. I don't learn the formula with teacher. Just go by 4 and start the formula. Isn't it? You know, look on it, supposed to look on the view of a teacher first. So look on a different way for. Can't bother doing it now. Where's that now? Which question? 2022. May 2023. Hey, look here, tell me which question you want the next. Yeah, 2023. Well, I'm going to go through something. Which one? 2019 are your favorite things. Which paper that? June? June 2023, right? '19 June paper was a different kind of question. Just pattern in the numbers. We can do it still. I'm gonna put it up just now. Huh? Yeah, man, some of them remember. Some of them kind of special and I remember them. Them unique and different. When they're unique and different, you remember them. And when they give people problems, you remember them. I know that that question and that paper give a lot of people problems, but it's different. It never come as a normal pattern. So some number pattern. It's easy still enough. But which question we look at? Number? Pass it.
This one, if I find it once.
Let me show you. Oh, this one give you the table. All right. So this is the table, right? So we have to understand about a quadratic function that is symmetrical about an axis of symmetry. So for example, like we have a shape like that. There's an axis of symmetry down here that passes through this point, which is called the vertex at the maximum point. All the y values, so if you draw one graph, like if you put this on a graph and go so. All the y values that are equidistant from that axis, the same y value. Right? So those values are, that pattern is also shown in the table of numbers, right? Especially when the interval of these x values is constant, consistent, which is 1. It's 1 this way, 1 that 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 way. So there's no gap in the pattern. The pattern will also follow now in these numbers. So when I give me this question, I'm looking at these numbers to see any of them repeat. Because I know that the values are the same outwards from where the axis would have been in the graph, right? So I'm trying to find a number. So right now I don't see any that is the same. I need to find at least one. Let me say one that is repeated, and I can figure out the rest. Because the values are symmetrical. So let's say I say, okay, I'm going to choose an easy number. Let's say I work out for 1. Work out the value for you and see what it is. And I can't help me to find the rest of them. To get the value here for 1, I take the 1 and I plug it in the function. It works out down here. So when I plug in 1 in the function for here, I'm going to get -1 squared. Remember, this one is not squaring in it. This minus is not squaring. And then now you add back the 1 here. And then you add 7. This becomes 8 minus 1, don't it? Which is 7, right? So it works out to be 7. So the value right here is a 7 right now. So voila, I'm good to go. Those are my that will help me to fill out the rest of them. Because those are the same. No, the maximum value cannot appear twice. Because remember, it only has one vertex, has one maximum value. So in the table of values, there's only one point that has that maximum value. So once we see these two, that can't be the maximum value. So it means that the graph must go above that. Must go above the 7. I mean, say you have 7 on a side here and 7 on a side here. Those y values. So the maximum has to be a value higher than 7 in between them. All right. So I'll populate the rest of the graph based on this symmetry now. So to the right of this 7 is a 5. So to the left of this 7 is also a 5. So you see them two match up, right? To the left of this 5 is a 1. So to the right of this 5 is a 1. See that? Then now, to the right of this 5 is a -1. So the left of this 1, sorry. So to the left of this is a -5. I don't have to calculate all of them. Now watch me now. My symmetry is right in between here, so that kind of represent my axis. It kind of represent this line right here. Because the values are equal on either side of that line, this way and that way. See that? So that red line that I've drawn on the table now would be synonymous with my axis of symmetry. So it means that the x value right here is 0.5. which can be calculated, but we can figure it out easily. Then now the y value correspond to that 0.5 is obtained by putting the 0.5 in the function. That's how we get the maximum value. Put it in this. So it will be negative 0.5 squared plus 0.5 plus 7. What that work out? We work out to 7.25. So it means that my maximum point is actually 0.5, 7.25 above the 7. And even though they did not give you in the table, you have to show it on the graph. Because a part of the function. You have to know that a quadratic graph has a maximum when the x squared negative and at a minimum when x squared positive. So you have to include this on your graph, even though it was not a value in the table. It's still a mark, it's still a point. And I think they asked for it eventually. They asked for it down here. See there? No, you can also get the maximum by computing the square and all of that. Simple. Complete the square and calculate it. I don't know. Remember, you're way that you the maximum of that minus 8. If you calculate the a square, you're going to get minus 0.5. And the k is going to come out to be that. If you use the h and the k. So that is it. So that's how we get it. It's in the table. Sometimes some of the maximum they give you these questions actually on the table as well. So that when sometimes they give you the maximum is on the table. With that method, you can kind of line out where it is. Get me? All right. Good? All right. Which question you guys say now? Which question you want to know? 2019, your favorite paper. That's why it's a favorite paper. You should learn a lot from it. Papers will give you a problem, you're supposed to learn a lot from them. The papers them will run through easily. You don't really learn nothing from them. Papers where you have to actually think and questions are different and special. You learn from those papers. Those are the papers you must like. The ones that really help you to improve. Like this one. This paper, a lot of people call over this paper this year when this one setting on. They give a pattern and they give a pattern of numbers. All right, so let us add this to the show that part 3. Let's add it to right here. So. And then put on the screen, give it 10 minutes to do it. Part 3. Show that U20 minus U19 is equal to U19 minus U17 equal to U19 minus U17. Show that to me. All right, there you go. Well, you want part A too? Hold on. It's 2 parts, sorry. A part A over here. And a part B in 2019. In 2019. Here it is on the screen. Part A and Part B. 2019. Start. 10 minutes. Easy question. The pattern question. Kind of different, a special list. Yeah, there's some facts around it. Right. Good. Hello? Hello? I don't think, no make no sense, no, 'cause we're soon finished. We basically have the last thing that they want to do. Because the topics that we did today were like the easy topics, and the body was just thing. So yeah, man. So tomorrow, we can come tomorrow from work. Tomorrow evening. But we're soon finished now. I don't mean a sense in come now. I was soon finished. So yeah, man. Cool. All right. Guys, Yeah, I guess that you. Sure. What is this? No, what very easy. No, what stands super easy. So that what is about people know what? Sure. What is it? Easy. Good wisdom. About people. So you have to be able to do this. Yeah, focus on man. Sir, you can make a lot of these. I really think what is surprise. Surprise, messy. Special. Ready? We're going to do it? Yes. You're going to talk. There's a that. Pick up mark. Pick up mark. All right, let's stop it. Ready? Let's do this one. Come on. Question says the nth term T1 of a sequence is given by this. So the first term is when n equals 1 right there so and 1 right there so. Second term is when n equals 2 there so and 2 there so. Third term is when n equals 3 there so and 3 there so. Question says show that the first term is 1. First term is when n equals 1. So T1 equals 3 times 1 squared minus 2. That's 3 minus 2 equals 1. So T1 equals 1. The first term is 1. Too easy. Next part says, what is the third term? What is the third term? Third term is when n equals 3. So put in 3 in this formula. So T3 becomes 3 times 3 squared minus 2. 3 times 3 squared is 27. 27 minus 2 is 25. So this equals 25. And 3 squared is 9. And 3 9 is 27. And down here, so said, Tn is equal to 145. What's the value of n? Put the formula. Tn is 135. The formula is 3 times n squared minus 2 equals 145. This is Tn equal 145. Subtract, add this over this to get 3n squared equals 147. Divide by 3, but forget. N squared is equal to how much? That looks like 49. What's up? 3 root of 49, n is equal to 7. Said easy now? Yes. Next part. Next part says, the next part says, the first 8 figures of another sequence of term n. This is just another way of writing Tn. So the first term is U1. Second term is U2. Third term is U3. That's all that is. That's how we have writing to term, especially the terms. So see there, I tell you, U1 is 1 right there, so. U2 is 1 again right there, so. And this is formula for a term where n is equal when n is greater than 3. When n is greater than 3, this is the formula. What is it? It's the difference between a term and the preceding term. Look at it. That's what it's meaning now. N minus 1 minus 1. That's it. So for example, the 5th term and the 7th term would be U5 is U4 plus, not the difference, the sum. U4, the sum, a term is the sum of the previous 2 terms. You see it here? This is equal to the sum of those 2. This is equal to the sum of those 2. This is equal to the sum of those 2. This is equal to the sum of those 2. See there? A term is the sum of the 2 preceding terms, the 2 terms in front of it. All right? That kind of sees. I don't remember the name of it, but anyway, that's not relevant with you. It's part of the pattern. So a term is equal to the sum of 2 terms before it, right? Good. That's why U5 is the sum of U4 and U3. U7 is the sum of U6 and U5. A term is the sum of the 2 terms before it. Write down the next term in the sequence up there, so. That's U19 and U10. Write them down. Let's add them on to this. So the next term will be the sum of these 2, don't it? This one the pattern, don't it? That will be 34, don't so? If you add this and this is 34. The next term now is going to be sum of these 2. That will be 55. See that? Done. So this is U9 and U10 are 34 and 55 on that pattern up there. So that term is equal to the sum of the 2 terms before it is on this pattern. Let's continue. It says what? Remember about this. What term in the sequence is what term in the sequence is the sum of U18 and U19? What term? U20. 20th term. U20. i.e. the 20th term. That's the sum of the 2. This should be the 2 terms before 20, don't it? Good. The question is easy, man. Next part now says, show that this is equal to that. Show that this is equal to that. So what am I going to do? I'm going to take that side here, put in what they equal to individually. I must work out with this. So see here now, U20 minus U19 comes equal to, what is U20? U20 is the sum of the 2 terms before it. U18, no, U18 and U19. Minus U19, now the 2 terms before U19 will be 18 and 17. U18 and U17. Let's simplify. U18 minus U18 that gone, don't it? That's all. So we have this U19 left right here, so. And minus U17 right there, so. Shown. See there? U19 minus U17. Done. Just stand done. Is that easy now? Which one next?
Yes, sir. Questions like this don't come. For number 7, questions like this still come.
Yeah, I never know what can come in on. This one was what? 2019?
Yeah.
One of the most set the pattern now, simple pattern most of the time, but ever so often them bring something a bit different. So I don't know what's gonna come. I would try to make sure I understand this question in case. Just in case they decide to come into
Okay.
Then to be consistent with the way all the questions set up. It is the pattern question, the diagram. You can easily work out the formula, add the same number of values each time and stuff. They can make it very simple.
All right, sir. Thanks.
Which question next?
You must say the body in your arm. I walk. See me? So my eyes. You know, say now much. I don't know. I see yourself. So when my eyes me find go man, I say, ah, my leg, me can't afford it. So I think about great about me him. You see me?
What question next? June 2018. This one. You know, so in your quiet all the time. Question wants you to draw the fourth diagram, figure 4, and then complete that table, and then answer part C, that question below it. 10 minutes. Hey, Time, still 6 minutes left. Take one. I can't find it right here. I can't find it right here. We're ready, 2 minutes. 2 minutes past the time. Let's go. Sorry about that. Close the door. All right. So based on this, pattern to go from this to this was added. So this is what you keep adding on all the patterns, the same thing. So the next pattern would be to add this onto this shape right here. That will be the next shape overall. So I can just complete this and copy it down now. That's going to be my next shape. I'm going to move it down now. That's my next shape. How to go to that? Okay with that? Then we're going to fill out the table now. So based on the pattern, let's look for the pattern in the numbers. These going up by 2. That's a plus 2, plus 2. So since it's going up by 2, the formula starts with 2 times n. For the first figure where n is 1, total is 3. 2 times 1 is 2. You have to add 1 to that, make it 3. That's the formula. Over here, we're going up by 4 consistently, plus 4, plus 4. So 4n starts the formula. 4n. But the first figure is 8. 4 times 1 is 4. You have to add 4 to that now to make it 8. That's the formula. This is the next shape in the pattern. So you can add 2 to this to make it 9. Or if you like, you put 4 times 2 is 8 plus 1 is 9. And this one, you're adding what? 4 to this. So we could add the 4 to this and make it 20 right here. Or we could drop the 4 on this formula, get 4, 4 is 16, plus 4 is make 20. Anyway you want to look at it, that value here is 20. Then now for this line, to get the end there, we can put this formula equals 43. So for here, we're going to put 2n plus 1 equals 43. That's to get the value for there. Subtract the 2, we get 2n equals 42. Divide by 2, we get n equals 21. So right here is 21. Let's get the value for here now. You take this 21, drop it on the formula. We get 84 and 4. So right here is 88. That done. Next part now says determine the relationship between the number of squares S and the perimeter P of a figure. So basically what we want to do is connect these two formulae. See here, the S is equal to, the S is equal to 2n plus 1. And the P is equal to this. The P, and put it to the side. The P is equal to 4n plus 4. So we want to do really, you want to eliminate the n to get a relationship between these two. To eliminate the n, what I could do is multiply this one by 2 to make it equal 4n like this. Multiply it by 2. I want to eliminate the n. So multiply this by 2. This becomes 2s. This becomes 4n. And this becomes 2. Then to get rid of this n now, all I need to do is subtract these two equations. So I can subtract. So I can do this equation minus that equation, or this one minus this one, doesn't matter. If I'm doing this one minus this one, then it's p minus 2s on the left side, p minus 2s on the left side, 4n minus 4n that gone, 4 minus 2 is 2 on the right side. That is the formula. If you want to carry this over here, so then fine. P equals 2s plus 2. That is it. This figure is 2 times this figure plus 2. That's what we get to from this to this. That's what this is saying, which is true. Which question next? Which question next? This is what play the wrong music there. Oh. Which question next? You have no question from there. From yesterday, I have no question. What time is it? 6 o'clock. I'm going to end it now, guys. I'm going to say yes. I'm going to end it now. So tomorrow, we'll be back here at 6 o'clock now. Tomorrow evening, we'll be back here. Huh? 5 o'clock, yeah. So I'll be here. You can come and continue practicing tomorrow evening.
Sir, what time you said you'll be on tomorrow?
No, we're not going to be online. We're going to be in the class tomorrow.
All right, sir.
Cool. Bye, everybody. I'm going to end it now. Bye. Gonna do some multiplies.
Later, sir.
Again. All right, bye, everybody.
Later, sir.
All right, cool.